So hi everybody, welcome to Sunya IAS, welcome to your Forestry Optional. Today we are going to discuss the test number 1 from the Forestry Optional Test Series. Okay. Now here, of course, the Forestry Optional Test number 1 has the syllabus of paper 1A. Now there are some of you who would have written the test and then you're watching the discussion, but of course because of paucity of time there may be some of you who would directly want to watch the discussion and just see that what should be written in the answers. That is also equally fine, because again the litmus test is then when you have the test on the specific date. Okay, so then you should be able to properly be able to answer it. Fine, that is how we will think and go about it, right? So now one by one we will go about the things. Now additionally, for example, there are a few things I want to tell you at the very outset, because this is your test number 1. Okay, so with respect to answer writing, right, here we will stick to definitions as much as possible. In many questions you will find, for example, what are the objectives of felling, objectives of grading, objectives of regeneration, objectives of thinning. Okay, so for this, of course, it is always better if you are able to write down specific points, but I'll also tell you that there will be some common points. If you remember, across various questions you can use it, right? Third, in this question itself, in this paper itself, for example, I've asked you species from mangroves, cold deserts, okay, and in various things, for example, orthodox seeds, recalcitrant seeds, everywhere it is mentioned, write examples, and this is how the questions in the forest services exams are also asked. So treat these questions and the discussions and the model answers, okay, try to remember things right from them. You will see a lot of questions getting directly repeated from here itself. Okay, so the focus on the species, okay, try to cram here itself. Okay, fourth will be the diagram part. So wherever possible we will try to draw diagrams. Okay, and here even if there is a simple question, for example, there was a question on the coastal areas where the mangrove plantations happen. Okay, so there also a simple diagram of India can be drawn, and you can show, I will show you in the question itself how you could have done this and used that information. Okay, so these diagrams, not only the map of India or the cross section of a map of India wherever applicable, but some specific diagrams can also be drawn that you can also look into. Okay, and the last one would be overall applications. Some questions are based on applications, some questions are directly differentiate. Okay, so the idea here is that if you again go through this, okay, and of course when you're revising your notes etc., this will give you a good way, because again here what we are doing, we are revising the syllabus for forestry through some test series based questions, right? So focus on these elements, okay, and wherever applicable and possible I'll tell you how you can fetch extra marks, but your main takeaway has to be that you should try to write the extra things down, okay, and try to replicate it, or at least try to do that in the exam hall. Okay, that said, after seeing the test also, or after, let's say, when you submit your copies, whenever you want to discuss, you can directly reach out and contact me on this number 93191 78775 if you want to have any discussion about these topics. Fine, now let us start. Now the very first question, now it's only an 8 marker, but of course you have 5 parts to it. Okay, you have to define hardening of, bole, vermiculite, regeneration felling, Ortet and ramet. Okay, so here maybe a couple of terms are familiar to you. By the way, this is a compulsory question. Okay, so even if it's a compulsory question, and here if you are not familiar with one or two terms, no issues, try to write whatever you know for the remaining terms. Okay, so here for example we will start with hardening off, and then for each of the terms we'll try to go ahead. Okay, now when we start with hardening off, and this is something you've already done, but here I'm just trying to tell you, hardening off is the process, okay, wherein the seed, okay, overall, or we allow the plants to adapt to real conditions. Okay, so they would have been remaining in the nurseries or in a relatively protected stage, but the moment you take them out to harsher or drier or tougher conditions, that is the part of hardening off. Okay, so we go into harsher outdoor conditions, okay, so they were living in a protected stable environment, and here only 1 or 2 line definition will do. Okay, I'm just explaining you for the sake of it. Okay, hardening off allows a plant, okay, which is living or staying in a protected stable environment to a harsher condition. Okay, and whenever it is placed outside, okay, so here there is a shock that the plant will receive. It is this shock which is going to help it to become more adapt. Okay, so simple, it's a natural process by which the plant get adapted to drought, to cold, to heat. Okay, and again this is the nature's way of approaching it. Okay, so hardening off is overall beneficial in this sense for the plant. Okay, because this is the way of acclimatization, as we may say so. Okay, this is how we can talk about it, right? Now that is the first definition that you will give about hardening off. Okay, that what this basically means, and what this basically understand, and what you understand to it. Okay, so here just one line if I may add here, that because of this process of hardening off, it overall helps the plant. Okay, now it helps the plant overall to have better roots. Okay, better and stronger roots so that it can survive. Overall the cuticle is also, so for example, if there is a thick cuticle, so in the dry or the harsher conditions the plant will be able to survive. Okay, if the roots are also widely spread out, that also helps. Okay, so overall here better water retention mechanisms, for example. Okay, so here again the point is you don't have to write the entire thing, just one line definition and perhaps how this helps. Okay, so one line definition, it helps in the better root system, a thicker cuticle, and perhaps a better water retention mechanism. That's how you can approach the first part. Second is a pole and a bole. In my lectures also I've explained what this is. Okay, so what you can tell, just again to recap, you have a seed, we have a seedling, you have a sapling, you have a pole, P-O-L-E. Okay, so pole is the younger stage. Okay, so you have to talk about pole is basically a young tree which is an intermediate stage between sapling and a mature part. Okay, so here that is the first part, and again pole is going to be a very important part for timber production. Okay, whereas in the mature stage we find something known as a bole. So if you see this, okay, and again a diagram of forest or a tree like this can also be helpful. We see a stump, this is a part of stump. We use the term stump when we talk about coppicing. Okay, this is where around the cut is made during the coppicing. Okay, for example, this is the height of the stump, roots, okay, diameter at breast height. This is a term we'll encounter again and again when we, let's say, talk about, this is DBH. Okay, there is bole, B-O-L-E, there is a bark. Okay, so bole, through this you can explain, or perhaps through this you can explain pole. Okay, so just a one line definition I'll just tell you, you can write down. Okay, pole, you just write down, pole refers to a young tree. Okay, usually between sapling and a mature tree, that is pole, P-O-L-E, typically ranging from 10 centimeters to 30 centimeters. Typically ranging from 10 centimeters to 30 centimeters. Okay, so this is basically an intermediate product, that is what you need to know. Now talking about bole, B-O-L-E, for bole you can write, it is the main part, or it is the main trunk of the tree. This is, you see, bole is the main trunk, excluding branches, leaves or roots. Excluding branches, leaves or roots. And bole is the part, the most commercially viable part, that is used for timber production. Okay, you can write, it is commercially the most valuable part, because of, okay, its straightness and volume. Because of its straightness and volume. because of its straightness and volume. Okay. Third is vermiculite. Okay. Now, for example, when you have maybe heard about terms like vermi compost. Okay. So what happens? Vermicompost is basically a soil amendment. When added to soil, of course, this helps in overall the availability of nutrients in the soil. It is very overall lightweight and non-toxic. Which also helps. Okay. So as in soil amendment, overall it helps in improving the fertility of soil, helping restore, making the soil more alkaline. Okay. In all these elements it helps. That is the vermiculite. Okay. So you can write down three things that are very important here. It is used as a soil amendment. It is used as a soil amendment. It has very good water retention. Water retention, nutrient exchange, water retention, nutrient exchange, and aeration capacities. Water retention, nutrient exchange, and aeration capacities. Okay. It helps in soil structures, improving the soil structures, plus it also helps in seedlings. We know seedling. So in the early stages, early growth stages, it overall helps. So it helps in seedlings, the formation of seedlings in early growth stages. How does it help? Through water retention, through nutrient exchange, through aeration based mechanisms. Overall non-toxic, very lightweight, can be used to improve the soil. Okay. So that is why it is used in the silvicultural practices. That is why you can know vermiculite is what we have just understood. Okay. Another term that was used was regeneration, felling. Okay. Felling, you know, is the activity of cutting down trees. Regeneration is what? Generation, and you are regenerating something. Okay. So from the name itself, and there are different types of felling. Okay. One of them is regeneration felling. You can go for selection felling, etc. Right. So here when we say regeneration felling, it involves removal of mature trees. Okay. So as to create conditions for establishment of new seedlings. It can be both natural, it can be artificial. Okay. So regeneration felling is again what we are doing. We are removing the mature trees so that new seedlings can be established. Okay. So that is how you can go ahead in this particular part here, and there can be different types of felling, so you don't have to worry about that. Okay. There can be different multiple types of felling which we can talk about. Okay. Now here the main condition is you want to create favorable conditions for establishment of these new seedlings. Okay. And when we want to do that, there will be certain issues. Okay. So for example, you are removing the mature trees. Okay. Or you can remove some diseased trees. Okay. So that when you remove them, then only you can go for the new seedlings, etc. That can overall help. Okay. So here there are certain, let's say, objectives. Okay. The objective here, one of them of course can be timber extraction, which is the economic objective. Conservation of biodiversity, overall we can talk about the ecological perspective. That can be one of the objectives. So for example, if this question was not only of 1 or 2 marks, because here there are 5 things you have to write. If this was again a very longer question, regeneration felling and its objectives, so you can expand on this. Okay. So right from timber production, okay, to biodiversity, to improvement of soil health. You can even link this to sustainable, how sustainable this is going to be. Okay. So all these things can be written here. Okay. that you can go through. So again, a simple definition of regeneration filling and its objectives can be mentioned. Again, even if you write this, you'll get your marks. Okay, so that is one. Now the last part here is Ortet and ramet. Okay, now here there are, when we read about vegetative propagation, so here if we go very micro, and again this was a difficult part that was asked by UPSC this year. Okay, so again if we have to define Ortet and then ramet. Okay, now if you see the diagram here also, for example, if this part is Ortet, okay, this is again used in clonal propagation. The same thing, when it is cloned again and again, that becomes a ramet. Okay, so ramet is going to be genetically identical to an Ortet. So when you have a basic, let's say, plant, let's say this part is the Ortet. Okay, and when you keep on propagating it again and again, that is how you get ramet, and you keep on cloning it. Okay, so in simple terms, if you have to explain in just one line each, Ortet is going to be the main constituent, okay, which is used and which is again propagated various times, which leads to more and more ramets, okay, which is going to be genetically identical to an Ortet. Okay, so here, because we've understood what the basic is, just one line each we should know. Okay, Ortet is, you can write Ortet is the original plant from which a clone is derived. Okay, Ortet is the original plant from which the clone is derived, and ramet is the vegetative offspring of the Ortet. And this part you should write. It is for ramet, you can write down ramet is genetically identical to the Ortet. This is important to mention here. It is genetically identical to the Ortet. Okay, that you can mention. Another part, for example, why do you use them? So for example, again in cloning, okay, so the idea is here to produce the superior variety of trees, okay, to produce better clones. That is the whole objective. So ramet, just one more line, ramets are used to replicate superior trees for plantation. They are used to replicate superior trees for plantation. Okay, so till now I think we've seen 5 basic definitions here: Ortet and ramet, regeneration felling, vermiculite, pole and bore, hardening off. And here also every year you will see, at least in paper 1, some definitions being asked. So again, as you are doing paper 1A and paper 1B, whatever terms you are coming across, just put a star mark. So this can also be asked. So again, we have covered few of the important terms, but again this is helpful if you keep on doing it and make a note of it. Okay, now what are the objectives and the types of thinning in a forestry? Okay, in a very basic term, if I were to highlight this, so again, why do you do thinning? So here there are 2 parts that are asked. Okay, so here in these kind of questions, what you can do, just first I'll just to give you, just define what thinning is. A basic definition, one and a half line. Okay, basic definition. Objectives of thinning you can talk about. Okay, because for this also you will get marks, and then you will get marks for the types of thinning. Okay, now why do we do thinning operations? So whenever there is a growth that happens in a tree, etc., so thinning is done. Okay, so as to remove the deformities, so as to remove the disease stands, etc. Okay, to give an aesthetic appeal also. Okay, to ensure that all the parts related to the growth of the tree are properly ensured. Okay, so these are few of the things that are ensured in a thinning. So we'll give just one line definition. Objective also you can give depending on how much space you have. 4 or 5 objectives you can highlight here, and then we can talk about thinning. Okay, for example, there is a thinning from below from above. Okay, we'll talk about the different names here. For example, there is a selection thinning. There's a mechanical thinning, etc. Right? So here again, this is how you can structure this question: define objectives and types of it. Okay. So here there are a couple of things I would just tell you additionally that you can write and mention here. Okay. So one first thing. So thinning, in this you'll write. So here some forest stands are selectively removed. Okay. Some forest stands are selectively removed. Now when you remove the forest stands, for example, when you had these forests, if you remove some of the stands, they are competing for the same resource. Okay. So there will be reduced competition, and the reduced competition will enable faster growth for some of the varieties. So we will do so. Okay. So our objective can also be improving growth, having more vigor. So all these things can be there. Okay. And additionally, I told you, for example, for the diseased or some of the diseased strands, we will try to cut them down, thin them down. So what this helps in, so overall the stand which you get is more healthier in nature. Okay. So here just one thing we can write. So thinning is a practice wherein some forest stands, or we can even say some trees in forest stands, are selectively removed. This is important, are selectively removed to reduce competition among the remaining trees. To reduce competition among the remaining trees. Okay. Full stop. Thinning helps to maintain productivity. It helps to maintain productivity. And health of a forest. Productivity, how? Because more light, more air, other, let's say, variants are going to be available here. Okay. So thinning will help in this case because of reduced competition. And second, healthier stands will get promoted. Okay. Now what can be the objectives of thinning? Few things you can directly talk about. Okay. One objective directly can be economic, better timber exploitation or better timber produce, better and healthier stands. There can be aesthetic value, it will look better. Okay, so at least 3 or 4 points we can always say. See, economic value, we can have healthier stands. Okay, and for stands you can even say you can have more even stands, because we are going for more selection. Stands are getting selectively removed, so aesthetically also it is better. Okay, so that you can talk about. Then few more points from whatever we have written. Because it is selective, so you can ensure growth of only selected varieties. Okay, right? So this directly you can write down: promote growth of selected trees. How? You are removing the weaker varieties, promoting the growth of selected trees. The timber production angle I have already covered. Okay, healthier stands also we understand. Okay, this also helps in, by the way, controlling the outbreak of pests and diseases in future, because if the thinning is done in a periodic manner, this would always help. We can write that. Okay, then it can help in biodiversity. It can promote biodiversity, overall increase the biodiversity. So around 6-7 points we've written. This is how you can present the objectives. Then we move to types. Okay, what are the types of thinning? Right. So here again, if you remember directly from your notes, etc., you can directly write it down. So whatever types of thinning, so we can start. They see there is a thinning where that happens. Okay, so there is something known as a low thinning, which is known as thinning from below. Okay, so you can write this as low thinning. Okay, and the thinning from above is known as crown thinning. So there is a low thinning, there is a crown thinning that happens, there is a selection thinning, I've already told you. Okay, mechanical thinning is also there. There is also known as something known as free thinning. Now when you write them, just one line definition each will do. Okay, had this question be of more marks, let's say even 15 marks or more, then what you could have done, you can even drawn a diagram related to these thinnings also, that could have been slightly more appreciated. But here it's a compulsory question, and of course you don't have enough space, because one page this will take definition and the objective, so you are left with one page. So ideally you should try to cover as much types as much as possible. Okay, so here just a couple of one line each that we can talk about. See, low thinning, when you're doing the thinning from below, easily understood. For example, this is a tree, for example, and here you have this the understory. Okay, and here for example you will have the canopy layers, the suppressed. Remember, see, we had seen dominant, dominated and suppressed. You're doing the thinning from below, so you will cut down these areas. Okay, so here you can write down just, and please use the keywords when you write. In case you are new and you are watching this for the first time, I'll just again remind you. For example, if this is a tree, okay, notice the different canopies. Okay, so there are three terms that we generally see: dominant, dominated and suppressed. Okay, the suppressed almost is up to a half the height. Okay, this is around 3/4 of the height, the dominated. And dominant is divided into D1 and D2. Okay, where D1 is at the top, D2 is around 5/6 of the height. Okay, and if you have known, for example, herb, shrub and all these classifications, this is the lower bound areas. So what you are doing, and here in this case, when you're thinning from below, you're cutting down either the suppressed. If you cut down the suppressed, what will happen? The growth of dominant, co-dominant will be happening very much. Okay, and we'll even promote the growth because we are cutting these smaller parts down. Fine. So here in this part, when you write, we are writing about the thinning from below, that is the low thinning. So here just one line: trees from lower canopy like suppressed, trees from lower canopy like suppressed or intermediate trees are removed. Full stop. Dominant and co-dominant trees are retained to promote their growth. Dominant and co-dominant trees are retained to promote their growth. That is just one line, good enough to understand. Second is thinning from above. Here we can write trees. Now here, if you're doing it from the above, you are going to ensure trees from the upper canopy. That is why these keywords have to be there in the answer. Okay, now if you're doing it from the above, now you will target this area. This is above, from the above. Okay, this is known as crown thinning. So here you can write down trees in the upper canopy. What are these trees? Now you will use again dominant and co-dominant. Trees in the upper canopy, in the bracket also you can write dominant and co-dominant trees are selectively removed. To provide more space for crown development. They are removed, selectively removed to provide more space for crown development. Okay, and here everything is related to, for example, this sun. There are some good high quality trees which are not able to get enough of, let's say, sunlight. It is getting taken up by these tall trees, so you cut down the canopy in the above trees so that the canopy for the below trees can get explored. Okay, that is how you can mention this. Then you have selection thinning. Okay, so here the idea for selection thinning is we want to improve the structural quality and overall genetic makeup. Okay, so here dominant trees which are there of poor quality, I'm just writing with this, dominant trees of poor quality, they are selectively removed. Okay, so that the trees which have a better form, which have better growth, they are the ones that can be used better. Okay, so that is how selection thinning can be mentioned. Then we have something known as mechanical thinning. Okay, now in mechanical thinning, the trees are removed according to, it's a mechanical exercise. There is a fixed pattern that is followed. They are removed according to a fixed pattern. Okay, so here there is no selection criteria as such. In the earlier trait selection, we had to identify, okay, this is the tree I want to save, this is the tree I want to remove. Okay, but in this case, uniformly the trees are going to be cut based on certain fixed patterns. Okay, so that is the overall mechanical thinning, also known as systematic thinning. Okay, that is what you can mention here. Then we also have something known as free thinning. Okay, so here also, to maintain the strand structure and diversity, the thinning operation is carried out, which is overall the free thinning process. Okay, that is also something we mention and write about. Okay, now question number 1C, again an 8 mark, and again a lot of species are there, and this is how also I want to let's say introduce the species to you. Okay, so here what is happening, for example, write down the economic importance of the various tree species. We have Azadirachta indica, Dalbergia sisu, Cedrus deodara, Santalum album, and bamboo. Okay, now this question, and by the way, when you read your Silviculture of Indian trees, the very first thing that they highlight is the economic importance of the following tree species. Now again, this is just to so that we get familiar and we get to understand this better. So we'll see how to answer questions like this. Okay, so see, one by one we'll have a look at the species. The question is about the economic importance. Okay, so for example, if you're not aware much about each of them, what you can do, for example, each of them will have a certain degree to play related to timber. Many of them will also be related to construction. Okay, for example, in construction they'll be used. There will be certain medicinal uses also. For example, right from this Azadirachta indica, that is neem, we'll see that is being used. There will also be economic importance because of their export value. For example, when we say shisham, shisham is Dalbergia sisu. Okay, so used in, when I say construction, of course I am actually meaning more about the furniture part here. Okay, so timber, one, furniture, medicinal, even export value, right? Then of course, for example, when I say something like this Santalum album, okay, from which we also get oil, which can be used for in aromatic perfume or other industries. Fine, so the question says economic importance. Similarly, when we say bamboo, okay, so here also bamboo can also be used and has multifaceted uses, right? So for each of them, try to write down 3 or 4 points at least, okay, so that you are able to cover the minimum ground. Now here, the kind of species that are used are generally, you are more aware about them, right? From Azadirachta indica is neem, okay, which also has important role in agriculture, can also be used as a biopesticide. All these things have to be highlighted. Dalbergia sisu is shisham, extensively used in furniture, extensively used for timber. Cedrus deodara is deodar. Okay, Santalum album is something that you also read about in root parasitism. Okay, and bamboo species, of course, we know the various applications bamboo has. Okay, so now what we'll do one by one. So again, when you write the answer, Azadirachta indica, start with neem and where it is getting used. Okay, so I'll just read out some of the applications. Okay, for example, when we say neem, the medicinal part of neem is very important. It is antiviral, it is antibacterial, it is also antifungal. Okay, second, neem you can also write neem, or I'll just write about neem here, and then some important points related to neem. One will of course be the medicinal part, you can highlight this. Then its usage in agriculture, for example, it can be used as a bio pesticide. We also know about neem coated urea. Okay, so these two have to be in your answer in neem. Other than that, there are few things that we can talk about. Okay, for example, it is also an insect repellent, neem. Additionally, the neem wood, so timber will also be a part here. So neem wood is termite resistant, more durable. Okay, that can also be written. Other than that, neem can also be used for personal skin care, for soaps, for hair care. Okay, so for the cosmetic part, neem can also be used. We can write that. And lastly, it also plays an important role in soil fertility. So overall, a lot of economic uses that we can see for neem. That is one. Okay. Second, for example, is Dalbergia sishu, or that is shisham. So in the same format, I'll just write down shisham here. Here also almost similar points. We will start with the timber part. Okay, shisham gives us very high quality timber. Again, used for furniture making, exports. Okay, in addition to this, it is also used as a very important fuel wood in rural areas. It also has certain medicinal usages. Okay, so here actually the bark and the leaves of the tree are used for skin related problems, for wounds, and even for digestive disorders. Okay, that is there. Furniture, I've told you, you can even add, this can also be used in musical instruments, even for flooring work. So a lot of, let's say, things can be carried out through this. Okay, Indian rosewood shisham or Dalbergia sissu. Then you have Cedrus deodara, that is deodar. Okay, now Cedrus deodara is also used, similar points will be writing here also. Points like, same, I'll start with timber, we can go into construction, I can talk about furniture. This will also be of course here. In addition to this, the wood for deodar produces something of aromatic oil, that can also be used, right? We can talk about that. Okay, and just one point I'll tell you, that the deodar wood, okay, it is highly durable and it is resistant to decay, which is why it is used in various of appliances. It is used extensively in the Himalayan region. Okay, we know that it is a tree of the Himalayan region. Okay, so be it in temples, be it in bridges also, it is also used. That is why I wrote the construction part. In the traditional homes also it is used. Additionally, it is also used in its various other characteristics. It has a very high quality. Furniture also it is used. Okay, it is used in carvings. Okay, so construction, carvings, etc. It is used. Aromatic oil, that is also used here. Okay, plus one more part. Okay, it is having very much important religious and a cultural significance also. Okay, Deodar also has religious and cultural significance. Okay, so that also is an important part. Fine. Then we go for Santanal album, that is the Indian sandalwood. Okay, now for Indian sandalwood, few things that you should know. One, again I told you, the sandalwood oil. Okay, this oil is used extensively, okay, in cosmetics, in perfumes, right? This is there. Other than that, the timber is used for carvings, okay, furniture, handicrafts. So one, oil. Okay, so again terms like aromatherapy, this sandalwood oil is used. It is also used in timber, plus it also has certain medicinal usage. So almost you are seeing that there are things that are getting used. Export, this is also highly exported. These are the main parts that you can highlight here. Okay, just to elaborate on the medicinal part, it is also an antiseptic, it is anti-inflammatory. Okay, so be it acne, be it rashes for skin, this particular sandalwood related products are used. That is important. And the last that we are left is with bamboo. Okay, so for bamboo, again it is used. Let me write it down separately here, so all the things you can understand in one area. Now bamboo is used for construction, for furniture. Okay, for furniture, it is used for construction, it is used. Very important for books, etc. So paper pulp, bamboo is used. Okay, bamboo is also used for textiles and other products. Okay, so again a lot of things that you read in GS in terms of uses of bamboo is what you can talk about. Okay, in fact it can also be used in food. If you have seen the cuisines from the northeast, or I can generally say the Asian, South Asian cuisines, the culms that are there for bamboo, that are also used for food production. Okay, so here also we see various uses of bamboo. So this question was specific to economic importance. Okay, that is there. Again I'll tell you, for example in this test also what we've tried to do, see tree species, you get different types of questions. For example, one we have already asked you is the economic importance. You can also be asked about their phenology, which is something we have also asked you. Phenology is basically the calendar, okay, of trees. When the flowering, when the fruiting, when the leaf fall, all these activities happen. Okay, what are the silvicultural characteristics? Okay, for example, does it demand light, does it demand shade, what kind of soil it needs? Okay, all these kind of things are silvicultural characteristics. Okay, so when you understand where that particular plant etc is growing, you can understand it. Okay, and then of course sometimes related to seed, sometimes artificial or natural regeneration or some other attribute. These are generally the kind of questions that are being asked. Okay, so keep a tab on what are the things that are asked. Okay, so again sometimes what happens, the silviculture of Indian trees becomes a difficult topic to deal with. So if you divide it into parts, for example these questions are easy. Okay, so now you understand. Now if they give you any other species, let's say you're not very familiar with, at least 4 or 5 examples will generally be applicable. Fine. So as we move along, we'll see some of the other attributes also. Fine. Now this is a question I'm expecting all of you to write fairly well. This is an easy example, but what will differentiate your answer and what I would also be interested to see is examples that you give. Okay, now define mangroves. You can give a very simple definition, but for the sake of more, let's say, authority, you can write with the Champion and Saith classification. Okay, use this and then try to give the definition of mangroves. Okay, so for example for mangroves, certain keywords that you can use is these are halophytes or salt tolerant plants found in the intertidal zone. Okay, something of this sort you can do. And because the question is also telling you coastal areas in India with example, either in the introduction itself you draw the map of India. Okay, now here you have an opportunity to show, for example I'm also drawing the parts of Gujarat here also. Why? Because there is an opportunity. Why? I'll tell you. For example, I can show the Tamil Nadu, and here of course just for example Pichavaram mangroves of Tamil Nadu. Okay, then we can give example of Sundarbans, again coastal, and we can also give example of part of Gujarat. Okay, the Gulf of Kutch, and then also we can give specific examples as we discuss along. So the point is, what you've done, you can easily define mangroves. You can also give the Champion and Seth classification, where we discuss the different types of trees, for example, in India. Okay, so you can define mangroves, that these are salt tolerant plants in general. Okay, or you can even use keywords like these are ecotones, highly productive in nature. Okay, so again I'll just one line definition I'll give you, you can write it down. Mangroves are salt tolerant trees and shrubs, that thrive in coastal intertidal zones, particularly in tropical and subtropical regions. They can survive in saline, and this is also what is leading to the next part. They can survive in saline, waterlogged soils, and play an important part in coastal protection. We can even add biodiversity conservation. See, in this question you are just asked to define mangroves. Fine, so I'm not doing too much into detail. Another question, and that has been many times asked, what is the benefit, okay, or what are the ecosystem functions of mangroves? So for that you can have your own a lot of points. We will now talk about what are the physiological adaptations to salinity. Okay, describe how physiological adaptations to salinity influence mangrove vegetations in the coastal areas of India with examples. Okay, physiological adaptations that happen to mangroves. Okay, some of the things you already know. Okay, so for example, they specifically with respect to salt, what they can do. Okay, so they can either go for filtration of this salt, absorption, or removing the excess part of the salt here. Okay, so either they can exclude the salt, that is something that you can write. Okay, and for each of these parts I will give you certain examples. I can even add the osmotic part here. Okay, so there are few points that we'll talk about. Either they can exclude the salt, or you can even say this can be the ultra filtration that can happen here. See what happens if the salt, there is too much of salt, there are certain mangrove varieties that will exclude it, some will absorb it and then excrete it. Okay, so for that salt excretion they will have salt secreting glands. Okay, other than that they will have succulents. Okay, so they will have thick stems, thick cuticles. They will also have aerial breathing roots. Plus vivipary. Vivipary is how the seeds germinating in the tree itself. They will not fall on the ground, but they will germinate in the tree itself. Okay, so that is what we can write in this particular part. Okay, so seeds germinate in tree itself. Okay, now one by one, because we should also remember some of the example here. For salt exclusion, I'll write the examples through. Okay, so you can write Rhizophora. If you don't remember, you can write down Rhizophora spp, that means Rhizophora species, or I will just give you one example, Rhizophora mucronata. So the Rhizophora species exclude the salt, that is, there is a lot of ultrafiltration that happens. Okay, then for salt excretion, okay, which means they have salt secreting glands, we can give example of Avicennia species, or specifically Avicennia marina. And again, of course, you have to underline. Okay, you can give the example of Avicennia marina. Okay, so again, just to give you what they do, so they have salt secreting glands. From these salt secreting glands, they secrete out excess of salt, Avicennia marina. Okay, right? Plus same example you can use in succulents also, Avicennia marina. So till now we have seen Rhizophora mucronata, we have seen the other example here. Okay, then for example, when we write aerial roots, we can say pneumatophores. Okay, so here same examples we can use, either you can give example of Rhizophora or Avicennia or Brugueria, because they will show similar attributes. So pneumatophores, these are aerial breathing roots. The roots needs to breathe, otherwise they will not be able to germinate, or they will basically, the roots will not basically be able to breathe. Okay, they will rot. Okay, same issue we also see here also. Okay, for example, vivipary also, you can give the similar example, either of Rhizophora, etc., because they will generally show the similar attributes. Okay, talking of osmotic regulation. Okay, so here there are certain species which are able to tolerate high salt. Okay, they are tolerant to high salt concentrations. Okay, so all these are the physiological adaptations that are there. So you should try to write at least 4 or 5. I've given you 1, 2, 3, 4, 5, 6. Okay, some are tolerant to high salt conditions in the cell itself. So osmotic change concentration, vivipary, pneumatophores, succulents, salt excretion, salt exclusion. These are the parts. In the coastal area with examples, so we have seen certain examples, plus your diagram where you talk about Sundarbans, where you talk about Pichavaram. In Sundarbans, we can give example of the different Sonartia or even the Avicennia related species, or even the Rhizophora in Gujarat also. So this is all that you have to write. So you'll be, if you mention all these parts, you'll get the full marks. Okay, so this is how you can attempt this question. Now next part is analyze the key factors that are influencing the successful establishment of seedlings in forestry. How do these factors impact the overall forest regeneration and growth? Okay, so here also please note, this is not one question, there are two parts to it. The first part is related to key factors. Now here there can be many such factors. Whenever you are confused in key factors, either used climatic, topographic, okay, biotic, edaphic, and then you can add and maneuver some more. Edaphic means soil. In biotic also you can create certain factors here. This is one way to present. Okay, I'll tell you other way also. And the second part is how does factors impact. So you have to address both the parts in this question. Okay, we have to try to answer both the parts. How we can mention about this, the key factors and the impact of these key factors. Okay, so one by one we'll have a look at. Okay, so the first part, and overall we will see. So first I'll just tell you overall the impact. You already know this. We have to talk about the positive parts. This will help in the healthy growth of forests. This will promote the biodiversity. Okay, this will promote sustainability. This will promote economic growth. And again here generally we'll link economic, social and environmental. I'm just telling you how you can think in the exam also. Okay, on the health, on the biodiversity, on the sustainability and the economic potential we'll talk about. However, we'll talk about now the first part, which talks about what are the key factors, okay, which play an important role in this particular part. Okay, either you can borrow from this climatic, edaphic, biotic, topographic, or you can write down one by one factors. So for example, how good are the soil conditions? For example, you can talk about light, availability of light, important factor. Overall moisture. Okay, how are the disturbances being tackled? When I say disturbances, I am referring to the biotic, which means pests, even disturbances like forest fires. How are they being tackled? This will also affect how the site is going to be. Okay, then a very important factor here will be the quality of seed. Okay, additionally we can also talk about temperature. Okay, we can talk about how much competition is there, which can be one of the biotic reasons also. Overall, how is the vegetation being controlled? Okay, so this is also something we can talk about. And lastly, overall with respect to the management of site management or silvicultural management. Okay, in fact the fifth part that you can even add here is something related to management. Okay, so almost all these dimensions have been covered when I'm writing like this. So for each of the part you can explain and move forward. Okay, right from soil conditions to the light to moisture to the disturbances. Okay, be it how good is the pest and disease control, how are the diseases going to be managed, etc. Okay, so first is this basic part. Now what you should do, again I'm telling you from the answer writing perspective. Okay, for example, when I say soil is the edaphic part. Okay, so now you should know 2 or 3 keywords related to soil. Okay, for example, you can talk about the pH of the soil, how is the nutrient availability, the soil structure. Okay, these are good enough, because if this is properly chosen, this will directly impact how the establishment of seedling will happen. Okay, for that we need to know the exact knowledge. Okay, whether the soil is too acidic or too basic. So this is going to be an important part. Okay, right. So here just one example I'll give you. For example, if a soil is nutrient deficient, so what will lead to this? It will have poor survival rates, growth will not be happening very well, as opposed to soil that is rich in nutrients. Fine, one example. Another example I can tell you is the soil structure. A poor soil structure will also lead to poor growth. That is something we don't want. Okay, so this is how the soil conditions are also going to impact, right? Second, for example, I say is the availability of light. Okay, now for example, we can say, now it depends. See, when you are in a seedling stage, you want appropriate light. Okay, if there is a very dense canopy, light will not be able to percolate. Okay, in a dense canopy, so seedlings will not be able to get light and they will not be able to grow. So in the seedling is a very young stage, in that we want access to light, for example. Okay, so if we have some light demanding species, you want to have you don't want a dense canopy. A dense canopy would not let the light come in. Okay, so light also plays an important role. Similarly, when I say moisture, okay, so for example, think about waterlogged areas, waterlogged conditions, moisture will not be sufficient. Okay, similarly, if the area is drought prone, water or moisture supply is not particular, it can also lead to poor survival rates if the species is not drought resistant. Okay, you can give that example. Pest and disease control. Okay, so if there is a pest outbreak and if it is not getting controlled, so of course the deaths or let's say poor propagation of these species will happen. Same for forest fires. Okay, quality of seeds, we want high viable, high quality seeds to be available. Okay, this has to be a part, right? So what will happen otherwise? Poor quality of seeds means poor quality of seedlings, which means poor survival rates. Okay, temperature also. So depending on what exactly the variety is, here also I'll give you one example for temperature also. For example, if we have very harsh temperatures, okay, and the seedling does not is let's say frost hardy, or let's say in these conditions it is not able to survive, so that is also not going to be conducive overall. Okay, so that is something we have to keep in control. Same for competition and vegetation. If there is too much of vegetation, the resources competition is going to be high, so even competition management has to be taken into account, right? And lastly, site management, which means scientific silvicultural principles of management have to be followed so that the seedling can, or the establishment of seedling can happen in the most optimum manner. Okay, so which means proper site preparation, mulching, okay, or even let's say creating a debris, right? So creating overall a better environment for this, that is a part of site management, because in site management there is something known as site preparation. If all these things are done in a proper manner, then only we will have a proper successful establishment of seedlings. Okay, so again please note, what are the key factors we have understood? Okay, we can elaborate on that certain points, and then impact of these factors. It will help in the healthy stands, okay, better biodiversity management, sustainable, better economic outreach and potential. So please note, you have to answer both the parts, because generally what will happen, you will only address this part thinking that you are also addressing this. Okay, but just like your GS answers in UPSC, okay, in the civil services exam, try to address all the parts here. That will serve, or that will go a long way in our discussion. Okay, so that is one. Now discuss the key characteristics of cold desert ecosystems. Okay, how can the silvicultural practices be adopted to enhance the conservation and management of endemic species in these harsh environments? And then the question says, list 3 species found in the cold deserts. Okay, so we have to address all these parts in this question. Okay, so when you talk about this, we can give basic introduction of the cold desert ecosystems. Okay, perhaps you can even give here, of course you can give a very small cross section of parts of Himachal Pradesh and Ladakh, which can be, so again you can draw, okay, the crown of India for example, and then you can mention where the cold desert is found. Okay, the question says, for example, what are the key characteristics of the cold desert ecosystem? We'll talk about that, and then we'll say how can silvicultural practices be adopted, and for, of course, we have to give name of 3 species. Ideally I would say for mangroves also for cold desert, remember 5. Okay, that always helps. Okay, for example, we'll see Salix alba, we can talk about sea buckthorn, that is Hypophae ramenoids. Okay, I can give the example of juniper species. Okay, there are other species, I'll just tell you. So what are the key characteristics? Very easy way to understand. Think about the kind of temperature you find. Okay, so for example, if I talk about the temperature, here there are extremes of temperature in cold deserts. What is the precipitation here? Very low precipitation. Now keeping this temperature in mind, now think about the vegetation. The vegetation is going to be very much sparse. Okay, very less vegetation is available. Then link with this biodiversity. So biodiversity is also going to be very less. Very few varieties that we'll see. Okay, so less biodiversity or very low biodiversity. Think about the soil also. See how we are organically creating points. The soil would not have enough nutrients here. Okay, that is also a challenge that we say. Okay, so one, there will be low water retention here. Second, the nutrient availability is also poor. Okay, so I can say poor nutrient availability. And again, when you write this, you can write it like this. So the examiner would also think that you've mentioned 4 dimensions properly. What is the temperature here, what is the vegetation, what is the biodiversity, and how is the soil. Okay, so that will, on almost for each part you will have around 1 or 2 points. So roughly around 7-8 points you are writing directly in the first part, that what are the key characteristics of these cold desert ecosystems, and of course because of that there are certain adaptations. Okay, by the way, that is a separate topic also, that what are the morphological or the physiological adaptations that the cold deserts or the plants found here have. Okay, but we will first of all understand the first part, temperature wise, vegetation wise, biodiversity wise. Okay, that for example there is a high diurnal variation, so between day and night the temperatures vary a lot. We see extremes of temperature, low rainfall, very less vegetation, because of less vegetation less biodiversity. Okay, poor water retention, poor nutrient availability in the soils also. So these are the characteristics of the cold desert ecosystem. Okay, now how can silvicultural practices be adopted to enhance the conservation and management of endemic species in this harsh environment? Okay, so the question basically is saying what can be done. Okay, so again, one, from the water perspective we can write about. Okay, which can be, for example, better water conservation, specific points. For example, we can talk about how we can use drip irrigation. Even we can talk about, for example, precision silviculture. Now here also other points, because see the question is silvicultural practices, so it has to, it will be very broad. Okay, here also we have to ensure, for example, control related to grazing, which means from herbivores and also from humans. Okay, first I understand the structure, then I'll tell you more specific points. This also has to happen. Then you have to go for endemic. So what also happens here in these regions, we also find there can be certain invasive species also which will threaten. So as much as possible we have to go for assistive regeneration through native species. Okay, so based on this, a couple of points I'll just let you know, so you can write some of the points related to this. Okay, so first major part will has to be water conservation, water management or irrigation. So here one point can be drip irrigation, another point can be the use of micro catchments, and overall water conservation, because these regions already have very less precipitation, so that is a part. Okay, additionally you can also mention use of mulch or mulching, overall can also help as a layer. Okay, so one can apply mulching around the seedlings to help water loss, to help reduce water loss. That is the part related to this. Okay, talking of control, and here of course we can go for grazing, we can go for fencing. Okay, because the vegetation is already less in some of these regions. If there is uncontrolled grazing, so that will also be dangerous. Okay, so that can help. So here either you can write controlled grazing practices, fencing. Okay, so this can overall help. So for water we've written, for biodiversity we've written. Acha, one thing we can even write more is for related to soil. The parts we've outlined as the problems, we can write the soil is of low nutrient, we want to have more nutrients, which means we can apply soil amendments. Okay, so what we can do, organic matter can be added, biofertilizers can be added here to improve soil fertility, erosion control mechanisms can be used, mechanisms for erosion control, that we can write. Okay, then when we write about this first part here, assisted regeneration through the native species or the species that are adapted. Okay, when I say these species are adapted, which means they're adapted to cold conditions, to drought conditions. Okay, so here that is what we can write here, right? And here also is you can use keywords that if you have to plant the seedlings, they have to be hardened off. Okay, then only they have to be planted, right? This can improve the success rate of these assistive regeneration, because we want to plant the seeds which can thrive in these regions, otherwise they would not even survive. Okay, so that is how you can write about this part here. Now moving to the last part, you have to write down the name of species overall. So I think a couple of species I've just told you, they have mentioned certain species. Okay, so here we will write down one by one, list down the 3 species found in these cold deserts. Fine. So here let me write down one. I've already told you is okay, species. First species is juniper, which is known as Juniperus polycarpus. Okay, Salix alba, which is the willow basically that is used. Okay, then we have Hippophae ramnoids, that is the sea buckthorn, Hippophae, and you have Rhamno. This is known as sea buckthorn. This is something you should remember. Okay, sea buckthorn is also known as lay berry. It has important nutritional medicinal use also. Okay, in your GS also perhaps you may have heard about it, sea buckthorn. Okay, so this basically I'll just write with another color also so that you remember. This is juniper, this is the willow, this is sea buckthorn. Okay, this is what you can write. Plus you also have other species, for example birch species also. A couple of other example I'll write down. Birch, BIRCH. Birch is known as, we've seen in the foundation lectures, Betula utilis. Betula utilis is birch. That can be the 4th example. I'll write 4th here. The 5th example that you can also write is Populus ciliata. CILI, Populus ciliata. That is again poplar. Again repeating, Juniperus polycarpus, Salix alba, Hippophae ramnoids, birch, that is Betula utilis, Populus ciliata. 5 examples, although you're only expected to write 3. And again, I hope by now you're able to understand how to structure these answers. Okay, temperature, vegetation, biodiversity, soil, and within that, even if you write down for all these parts, you will be able to understand how to address this. Fine. Next we write, and again this question is important to understand because slowly and steadily you'll understand how to attempt these questions. Acacia catechu, brief account of phenology, silvicultural characteristics and methods of regeneration for Acacia catechu. Okay, and for example, if you directly get a question, okay, related to Acacia catechu, now you can break this down. Phenology you can mention, silviculture characteristics, even economic importance, and even methods of regeneration. Okay, so sometimes even if they give you a silviculture of this Acacia catechu, write down all these parts: phenology, silvicultural characteristics, method of regeneration here. Okay. Now, first, see, there are two ways to prepare this topic. One is, of course, you can cram it, but second is you can try to understand, right? For example, Acacia catechu is known as khair. It is thriving in these very dry desert-like conditions, okay, and it is basically a deciduous. So there will be a season specific time where this will shed its leaves. This is what the deciduous trees do. Additionally, I have told you these grow in dry, or I can say arid or semi-arid conditions where the water will be less. So they will be drought hardy in that extent, okay. So if you know that, of course, this is the local name is khair. These are found in drought or conditions where you do not have enough availability of water, right? These are deciduous, so they will have enough time. So we'll break this down one by one. First part is phenology. Phenology for us is very simple, just like we have a calendar, okay. A calendar is where different things are mentioned. For them, the calendar will be when the leaf fall will happen, when the leaf will fall, okay. For example, when the flowering will happen, when the fruiting will happen, when the germination will happen, okay. These are the steps. Similarly, what are the silvicultural characteristics also, okay. So here also we will understand what are some of the parts that you need to know, okay. For example, what are the silvicultural characteristics, okay. So here, for example, I'll write it here. Some things that you can remember. What are silvicultural characteristics, okay. So for example, what kind of soil do they prefer? Availability of water, availability of light. Is it a light demander or not? For example, is it able to coppice? Okay. In fact, you can even mention as 0 its overall size, okay. Some basic part etc. related to this, or the growth related to it. These are the part that is of importance to a silviculturist, okay. What kind of soil, availability of water, whether they'll be able to survive in low water or high amounts of water is needed. Now for this, most of the things you will be able to understand, right? Why? Because we already know these are present in very desert or semi-desert like conditions, arid conditions, fine. So that is how you will be able to understand in this part here. Give a brief account of phenology, silviculture, and then is the method of regeneration. Here I'll tell you artificial method also and the natural method also, okay. So that is how you can understand this particular part, okay. So here in these kind of questions directly also you can start with phenology to some points, silviculture few points, method of regeneration. However, because we know about Acacia catechu, so you can talk about what is Acacia catechu, just a 1 or 2 line in introduction, and then directly start with the phenology, okay. In the introduction you can mention its local name, where it is found, so that you also tell the examiner that you have certain idea, okay. So just one line I'll tell you. Acacia catechu, the common name or commonly known as khair, Khair, is a medium sized tree, that lives in dry or arid conditions. So what keywords I've used here? One, I've given the natural the local name, if I know, medium size, okay. Where does it live? In dry arid conditions. Then it is known for its timber, tannins. Tannins are the non-timber forest products, timbers, tannins, and its medicinal usage. Okay. Now because we know that this is going to be, so that is the part. Now phenology, you don't have to tell examiner what is phenology, they know, okay. We will write it in these 4 elements, phenology, okay. So what happens? Leaf fall is known as the leaf shedding. The leaf shedding will happen in the dry season, okay. So from February to March or parts of April, the leaf is going to fall in Acacia catechu. That's the first part. Okay, so you can write down, just write down leaf fall dash. The tree shed its leaf during the dry season, February to March. February to March, the leaf fall will happen. Okay, this is the dry season. Flowering, when this happens? So here, just after this, the flowering begins to happen. So you can write, the flowering happens from February to April. Flowering happens from February to April. Okay, and just to give you a context here, so what happens, see, you have a dry season, and then after the dry season there will be a monsoon. So just when the dry season starts, the leaf will start to shed. Okay, why does the leaf shed? Leaf sheds to conserve the moisture. Otherwise, if the leaf is going to be there, the stomata will open, a lot of evapotranspiration will happen. So leaf has started to shed, and before the onset of monsoon, the flowering will start to happen. Okay, so just for your understanding, this is what happens here. Small flowers will come, and then they will start to take their place. Okay, so two things we have seen, when does the leaf fall, and secondly we have seen when does the flowering happen. Third thing is fruiting. Third thing is fruiting. For fruiting, the time is from October to December. Here what we have seen, from Feb to March. This is from Feb to April. Fruiting is from October to December. Fruiting is from October to December. So here you can just write down, from October to December, the fruits ripen. From October to December, the fruits ripen. Okay. And the last part is germination. So germination actually happens during the monsoon period. Germination happens. So you can write down, the germination happens with the onset of monsoon, because in the monsoon you'll have more moist conditions. This will help. Okay, so initially the seed has a period of dormancy. Okay, and when the appropriate moisture or water content is available, the basic germination starts to happen. Okay, so germination starts with the onset of monsoon. That is what you can write here. Germination starts with the onset of monsoon. Okay, so four things we have seen in phenology: leaf fall, flowering, fruiting, germination. Germination with the onset of monsoon, fruiting during from October to December, flowering and leaf fall during the drier seasons. Okay, that is the first part. Now silvicultural characteristics you can now understand, because this is again see, Acacia catechu is a survivor. Okay, survivor means it is going to withstand low, let's say tough temperatures, lesser moisture, lesser water availability. Okay, so one point you can write down, it is drought resistant. Okay, this will become drought resistant. So you will understand that, yes, okay, because even with a very little water, the roots will go deeper to find moisture. Okay, second, it is a light demander. It is a light demander. So for example, if the area is too shady, if it has a lot of shade, it will not grow well. It needs appropriate light to grow well. Okay, it can even grow in poor soil, which means even if it's a sandy soil, it's a rocky soil, it can grow. Okay, so it can even tolerate degraded soils with low fertility. However, it would prefer more of loamy soils. Okay, it has very good coppicing ability. It is able to coppice very well. In addition to this, because it is thriving in tough conditions, it is also fire resistant. Another point you can write. Okay, how is it? Because see, again, it has a very thick bark. The thick bark provide its this particular attribute. Okay, it is fire resistant because of its thick bark. So again, soil we know, water we know, light we know, it's a good coppicer, that also we know. Excellent coppicing ability. So whenever it is cut from its stump, it is able to regenerate and grow. Okay, these are the parts that you should understand. And then you're left with the method of regeneration. Okay, acha, I already told you size and growth. So here also one line you can write. It's a medium sized deciduous tree. Medium sized fast growing deciduous tree. Okay, if you want to remember, it is around 6 to 15 meters of height. Okay, but medium size, deciduous, fast growing, able to thrive in tough conditions. If you remember the tough conditions, fire resistant, light demander, drought resistant, even in tough soil conditions, coppicers, this you can know. And generally now when you see the silviculture characteristics, this is what is asked. How soil, water, light, coppicer or not, fire or frost, etc. So these are the few things that one gets to understand and know. Okay, so I hope this part is clear. Right? Then in methods of regeneration, the last part that we have to write. See, the method of regeneration can be both natural or artificial. Okay, in natural, of course, it will happen through seeds. Okay, so seed dispersal can happen. Dispersal can happen by water, by wind, by animals. Okay, additionally, there is a process that is known as scarification. The seeds which are present are dormant, they cannot directly be used. So there have to be, there is a process of weathering which happens. Okay, which helps to break the seed dormancy. Okay, so scarification is needed, plus you need some moisture available. That is why the germination happens during the period of monsoon, with the onset of monsoon. Okay, then talking of artificial, so you can talk about direct sowing, planting via nurseries, nursery planting, plus it already had good coppicing ability, so this can also be there. Okay, it is managed in Coppice systems, that is something we can also say. All right, so natural, artificial you've mentioned, just one line definition you can mention, and this is how you can attempt a question like this. Okay, so slowly and steadily when you practice this, I think in the next part also we have a similar question. So you'll get an idea about how to write questions like this. Okay, now we move to another simple question. Differentiate between orthodox and recalcitrant seeds. And the second part is slightly more tricky. This is where maybe some of you would not have enough content. Second part asks you to write about the 5 species. Okay, so this is also where you have to be alert and very much aware. Okay, that how to attempt questions like this. Okay, so we'll just have an idea and we'll just discuss what this happens. So you have 2 things. One is orthodox. See, ultimately you have to talk about the moisture, okay, and the level to which the desiccation or the drying can happen. In orthodox as well as recalcitrant. Okay, So first of all, this kind of question can be expected, okay, has been asked many a times. So my point is, we should always try to remember it, okay. And the very first point is the most important, that it is the orthodox seed. So when the drying will happen, this can be dried to low moisture content. That is the main part of point, okay. And this cannot be dried to low moisture content, okay. In fact, it cannot tolerate too much of drying, okay. So here it is roughly around 5%. It is, the moisture content is roughly around 20 to 30% here. So if we were to define just one line each, I'll just tell you. So one, if I say orthodox seeds can tolerate drying to a low moisture content to 5 to 10%, okay, which is why they can be stored for longer. They have longer shelf lives. The recalcitrant seeds, they cannot be dried to below the 20 to 30%, okay. So which means they do not tolerate drying below a critical moisture content. So you cannot store them for long periods. We cannot store them for long periods, okay. So here it tolerates greater amounts of drying, it does not tolerate great amounts of drying, can be stored for long, cannot be stored for long, okay. This can be stored at 0 or even sub-zero temperatures. This is very much temperature sensitive. So this can't be, this cannot be, okay. Now it remains viable even if you store it for long temperatures. It does not, okay. So it loses its viability very soon. So 4 differences that we have seen so far, okay. Plus if they are dried too much, this will cause an injury. So we also have to prevent this injury from happening, okay. So here few things that we have to see. This can be dried to low moisture content, this cannot be dried, 1 point. Second, can be stored for long periods of time, they cannot be stored for long periods of time. They can be stored at 0 or sub-zero temperatures, these cannot be stored at 0 or sub-zero temperatures. And last is, these are viable, okay, even for long periods of time you can still use them. These are not viable in the storage for long time, okay. That is the first part. Now let us write about the examples. Now for orthodox you can write down, we just saw an example, Acacia catechu, okay. So for orthodox here, let me write down some examples. Just now we saw about Acacia catechu, Acacia nilotica, for example, okay. We can talk about Prosopis judiflora, Albizia labec, okay. And we can even mention a couple of other species as well, okay. So we can even give the example of, for example, we can say the cassia species, that is known as cassia, okay. These are the orthodox species, whereas the recalcitrant species are the ones I'll just tell you, which includes the recalcitrant species can be Azadi Rakta indica, Jamun, that is Syzygium cumini, okay. So I'm just writing it here, neem, Jamun, Sal, that is Shoria robusta. We can even include Dipterocarpus, turbinatus, and mango. Mango is Mangifera indica. Mango is Mangifera indica. Okay, that is what you can also write here. Okay, and the last one was Dipterocarpus. Dipterocarpus turbinatus. Turbinatus. Okay, so that is how you can mention or write this question. That is your question number 2C. Okay, so here in these first few questions I've taken slightly more time to explain and how to write. As we move along, of course, you will get to know how to address the parts and how to write the points. Fine. Now we move to question number 3A, right? Now this question 3A, if you see, for example, for Shorea robusta, first of all you need to know that this again, either this can be asked to you as an explanation. So what they're asking you is the dieback phenomena. By the way, this question has already mentioned that this dieback phenomena is happening in sal, that is Shorea robusta. So what actually happens, let us see, right? So here in species like sal, Shorea robusta, natural regeneration often faces challenges like drying of shoot portion while the roots remain alive. Okay, so if you are asked to define what is dieback, this is the definition, wherein the shoot portion often dries up whereas the root portions remain alive. This is the basic definition of dieback. Okay, now the question says analyze the underlying factors contributing to this, number one. Okay, now for any forester, okay, or any silviculturist who wants to ensure proper regeneration of sal forest, moist sal forest, this becomes a hurdle, this becomes a bottleneck. So we need to understand why this happens, number one, right? Plus what steps can be taken, ecological steps and silvicultural measures, so that this problem can be overcome. Okay, now whatever steps I'll tell you, you can use it in other answers also. For example, if there is a particular problem in a plantation, or if there is a particular problem, what can be done. So I'll tell you a framework here which is very useful to address questions like this. Fine, so we'll see both ways. Secondly, whenever there is a question, analyze the underlying factors. Till now, if you've noticed in our discussions, we have tried to mention the causes in a framework. So here also I'll do the same. We'll see a framework about how to address this. Fine. So what are the factors which lead to this problem? Okay, so again in your basic silviculture you would have read climatic, edaphic, biotic as well as physiological factors. Here also in the same manner we'll see. Fine. So now what happens in the climate whenever the temperature is high? So because of high temperatures also, there is a part that the shoot portions do not get enough, let's say, resources, right? Plus high temperature is sometimes coexistence with drought like conditions. Okay, so very less moisture is available. So because of that also, because of these climatic reasons, often what happens, the drying of shoot portions happen. Okay, so if the temperature is excessively high, okay, or if there is low moisture, plus add to this the aspect of climate change, okay, which will make these conditions even more vulnerable. So this is the first reason why this particular thing happens. Now the moisture part, this will happen more in pre-monsoon. In the pre-monsoon phase, the moisture stress is considerably high, and during these conditions, of course, what can happen? Again, the dieback phenomena can happen in sal forest or in the Shorea robusta. That is one. Other than that, if there is poor, now these are soil factors. Okay, so soil compaction is poor, if soil aeration is poor. Okay, so if there is a compaction of soil, too much compaction, it also interferes with the natural regeneration. Similarly, poor soil aeration also leads to that proper moisture is not going to be available, okay, to the roots. In fact, the water infiltration cannot also happen because of this point. So that is also a problem, right? Other than that, biotic, you can understand if there is a lot of grazing pressure on that land, this also is a significant problem. Plus followed by pest or insect attacks. Okay, this can also interfere with the natural regeneration of Shorea robusta. Okay, plus the physiological, which means if there is a root shoot imbalance which is also seen. Okay, so if there is a root shoot imbalance, because of that also we can conclude and we can overall see this particular phenomena of the dying back which happens. Okay, now when the dieback phenomena happens, what can we do in terms of silvicultural methods, what can we do in terms of ecological methods? Okay, now again I'll tell you many dimensions, you may write some of them. So number one, for example, site preparation can be better, and again these questions you can use, or dimensions you can use in different answers depending on wherever you can use. Right now, soil working plus let's say organic cover or some non-organic mulch can be provided on the site. So if we prepare the site well, if the site preparation is done well, to some extent we can mitigate the effect. Okay, then there can be some silvicultural methods. Right now, try to use this term in your answers as much as you can. Okay, this is assistive or assisted natural regeneration. Okay, and this can also be done or helped through Coppice management. You know what is Coppice? Again, when you cut the tree to the stump height, okay, from very low height, and from that different, let's say from the shoots, the different regeneration happens. So in silviculture, what we can see here, if we go for assistive natural regeneration, we go for better Coppice management. This also can be a method. Okay, now to address the part of grazing pressure and insect attacks, of course we can go for fencing. To address the forest fire issues, we can go for fire management. These are all protective or the protection measures. Okay, this can also be undertaken. We can also manage the microclimate, okay, which can address this issue to certain extent, the high temperatures, okay, or the issue of moisture. One of them issue or one of the ways to manage the microclimate can be through the management of canopy. Okay, if the canopy is better managed, of course this can be taken into account. Ecologically, there are also other mechanisms which can be at play. For example, we can say inoculation by mycorrhiza. In fact, the last question of this test, question number 8C, is about mycorrhiza, and mycorrhiza does play an important role in ensuring these aeration of the soil becomes better. Okay, overall nutrient availability, especially for phosphorus, becomes better. So mycorrhiza inoculation here also can be done. In other cases, whenever you see what are the ecological methods, mycorrhiza inoculation, you can even mention VAM, okay, the vesicular arbicicular mycorrhiza. Conservation of biodiversity in that region overall can be a significant step that helps for this particular part here. Okay, now the presentation, when we are doing like this will also help you understand better. Okay, otherwise of course you can go through the answers also for basic content to understand. Fine. So for a question like this, you know how to address what are the various factors. Now within the factors, I've given you two factors each. You can even go more, you can even write more factors, but the point is to address all the parts of the question. So here also we have addressed the silvicultural methods also and the ecological methods also that needs to be taken into account to ensure, or which can be adopted to enhance successful natural regeneration of the moist sal forest. So from the moist we can understand it requires moisture. Without enough moisture there will be drying up, which happens, can be because of the root shoot imbalance also. Okay, I hope you understand this. Next question now we see, are non-native tree species a solution or a threat to forest ecosystems under climate change? Please note the term also, this under climate change. Discuss this with examples of species specific or species used in certain plantations. Okay, now this question I am assuming this can also be solved with whatever knowledge you already have, existing knowledge. In a question, whenever they are giving you two options, either a solution or a threat, write about both. It is both a threat also, it's both a solution also. Okay, and here whenever, now what examples can you brainstorm right now? Try to link those in the answer. For example, we can think about eucalyptus, you can talk about the Prosopis juliflora. I am writing eucalyptus species. Okay, we can also talk about other plantations that are there. Okay, for example, we can even talk about the non-native, for example, lantana. Okay, this also you read in your current affairs. These are very prominent examples that one reads about. Okay, and they have been very much harmful. So when you see the non-native tree species, of course they will have certain benefits. We'll talk about the benefits, which is the part of solution, and then we'll also show why are they a threat to the ecosystem, especially if this is under climate change. Okay, so here you can just give a if you want, just a very one line introduction about the non-native species, okay, which are of course not native to the ecosystem. The name is very much self-explanatory. So here the first part which says they are a solution. So here of course the heading can be this, okay, solution or threat. Now in our classes we also talk about the ecosystem services. So again I'll just highlight it just for your reference. See, whenever you just remember this framework, this is also there in your NCERT. The ecosystem services are 4 ecosystem services, and you can put it in any ecosystem. So whenever you want to write points, so you have provisioning services, we have regulating services, we have supporting services, and we also have cultural and aesthetic services. Okay, provisioning simply means to provide for. What can the trees etc provide to us? They can provide us timber, they can be used for furniture, for example. They can give us non-timber forest products, again used for fuel wood. Okay, again there will be certain regulating services, okay, regulating and supporting services. So again regulation of, let's say for example, the air quality, okay, purification, so water filtration etc, among many other services. Supporting, think in terms of seed dispersal, pollination, nutrient cycling, and cultural and aesthetic, which means, for example, let's say they are being worshipped for tourism etc. Now same thing, just put and think about the non-native species here. Okay, so here you can also borrow some points. For example, if I say non-native species, if I say mangroves, if I say cold desert etc, whenever you shorten points, use this framework. Okay, very easy to understand. So the very first thing is what is the benefit they provide? They provide certain important ecosystem services. You can give some examples here. Okay, they also help in climate adaptation. Now the question was talking about climate change, so I'll also give you certain points related to climate change also. Now there is a specific point related to climate adaptation, that they help in climate adaptation. Right now I'm giving you an example of Douglas fir. Okay, we have read about fir, okay, cher, pine etc in the higher altitudes. Douglas fir is an example from Europe. So I'll make you write down just one line, but let us continue and discuss this. They also have a great economic value. Why? You see, these non-native species grow very fast. Okay, they have very shorter growing periods. Okay, so because of their fast growth, yes, they provide us timber, pulp, paper, non-timber forest products. So there are a lot of benefits that we derive out of them. Plus they also help in climate adaptation. Okay, now for example, if we cut down a forest versus we go for non-native species and opposed to having nothing. So non-native species, even if it is non-native, still it is going to be supporting some biodiversity. So again, one point we can add is supports biodiversity, for example. Okay, helps in climate adaptation etc. So these are few things that we'll write, but there are also a lot of threats. The threats, for example, they don't have any natural predators. Because of that, okay, it leads to death of native species. So native species will die because of this. Overall biodiversity decline happens. You can give example of, let's say, Prosopis juliflora. I should have had the small j. Okay, there is a biodiversity loss specifically. The native species will die because of this. Okay, plus, for example, they will take a lot of water, so water loss will happen. Because of this, the ecosystem balance or dynamics will change. Okay, and because of this also the microclimate will also change. And again, I can even add, for example, the supporting mycorrhiza and other predators or prey, etc., will also get damaged because of this. And when you bring this into account, now again you can link your climate change. Now with increasing temperatures, increasing carbon dioxide emissions, okay, these changes will be far more pronounced. There is already a water stress. They will contribute more to water loss, which means more extremes of temperature, prolonged drought, prolonged stress. So here they will be more harmful if we go for this. Okay, so that is a problem. Plus I'll give you certain more examples from Indian case also. For example, if we talk about Western Ghats, okay, so we know Nilgiri Biosphere Reserve, for example, it has been significantly impacted by Lantana camara invasion, by Prosopis juliflora, okay, even by another example, Chromolena odorata, okay. These two you are more familiar with, so remember these two. This is one more example, or no issues if you do not remember. Similarly, if we say Central Indian Highlands, again a lot of fragmentation in the habitat has happened, okay. That is also a problem. It will lead to fragmentation of habitat, okay. So here these regions have been invaded by non-native species, okay, especially along these transition zones. That's also a problem in the Himalayan region also. So pine species, they were introduced for timber, but they have spread across a huge region, okay, and they have displaced or displacing the native oak trees, okay. So the ecosystem services that were originally being provided by oak trees, you will lose right from water retention. The pine trees, they will take up more water, biodiversity support will be less. So these are also some examples that you can write in this particular case, okay. And I'll make you write down the example which I was telling to you, okay. So where of course, so this is a challenge related. There is also a couple of good examples, okay, wherein some things that you would have also read in your current affairs, that also I'll tell you, okay. Now the example that I was giving you, the Douglas fir, okay. So here what happened, this is an example of Europe. Now this variety, it is a non-native variety, okay, and this has higher drought tolerance. Higher drought tolerance as compared to the native spruce variety. Now that's a huge difference. The native spruce variety is not overall much helpful, but this variety is far more helpful, okay. So that is just an example that you can write down, okay. The Douglas fir has higher drought tolerance compared to the native spruce variety, okay. So that is one example that you can write down, okay. Another couple of examples which I can tell you, and which we can of course discuss in this particular part here, okay. And for example, we are talking of, let's say, Prosopis juliflora, right. So here if we talk about, let's say, specifically the case of bunny grasslands, okay. So even the local communities have played an important role in the removal of these species which have invaded them, okay. So here certain ecosystem restoration practices have also happened, but again I will not say that this has totally been removed, okay, because again this will take a lot of time. But for example, in certain cases even its removal is being done. Lantana camara is a huge problem in Western Ghats, in other regions. However, in Bandipura, the local community is also trying to help and try to remove this, okay. So this also happens, okay. This is another part to understand here. So I hope you will understand both parts, how it's a solution, how it's also a threat, and try to give multiple examples. Here also in India I gave you ecosystem based examples plus other examples, so you will have enough content to write, okay. So I hope you are able to address this part. Right, now what is pollarding, okay, and how is it different from coppicing? Explain this with examples. Fine. So let us first understand what pollarding is. And by the way, in case somebody is not aware, in a very simple terms, if I say, let's say this is a proper, okay, proper tree here, the general difference, or let's say if I draw it, it would be better if you draw both. Okay, so here it is, the main difference lies in the height. Okay, so let's say this is a coppice. Let's say this is the height I want to tell you. We will study this and also write. And this is the example of okay. So coppicing, the general point is again the height. So this is the base, this is the stump. So if I, let's say, write down the stump height, so the main difference is going to come here in this part. Okay, whereas in case of pollarding, of course, as you can see, it is going to be higher, or let's say the height is going to be more. So the idea here is, there from this stump, okay, the regeneration will happen. Okay, so different shoots will try to emerge from this over a period of time, and that is why when we read about the silviculture of certain species, we see certain species are good coppicers, some may be poor coppicers, some may be fair, and some do not coppice at all. So let's say if I talk about conifers, conifers do not coppice. Okay, coppicers, okay, good. So again, this is something that has been asked multiple times, try to remember them. Okay, pollarding. And by the way, if you're seeing this, let's say if you still have not seen the foundation lectures, you can still go back. There were certain live streams that I done. From that also you can see these important examples. And same is the case with pollarding. So in this question, first of all, of course we'll explain what pollarding is. We'll also go into the differences, but we'll also tell this particular part wherein we talk about the differences. Okay, so here basic things we'll see. So pollarding is the practice of cutting the upper branches of a tree, typically above the head height, okay, to encourage the new growth. And the tree is cut 2 to 3 meters above the ground. Okay, so this is where the main difference lies. This is around 2 to 3 meters above the ground. Okay, in case of pollarding. What is the purpose? Of course, the new shoots, etc., they can be harvested regularly for timber, fodder, firewood, or even other uses, right? Plus, one major thing that also is there, to prevent livestock from grazing on the new shoots. Now here, because this is at above the head height, in this case the problem in the coppice will be that this is more prone to grazing, whereas pollarding is at a higher height. So here it also prevents the livestock from grazing the new shoots. Okay, plus in cases, of course, when this grows bigger, it can coincide or collide with the power lines or some urban structures. So to control the tree height in urban areas, to avoid interference with buildings or power lines. Okay, this is something we understand. Okay, and here what happens, basically the tree responds by growing new shoots, etc., they come out. Okay, so that is there. Examples of trees which are good for pollarding purposes. Okay, so here we can talk about salix. So examples like Salix alba, Frankinus or Tilia species, the ash or the linden. Okay, we can even talk about, for example, Hardwickia binata, which is also mentioned in your syllabus. Okay, so these are some of the prominent species that will go into pollarding. So that is again one of the examples that we can talk about in this particular case. Okay, now moving into some certain differences that you should know, some basic differences that at least we should be aware about between coppicing and pollarding is what we'll just have a look at. Okay, so basically you can, if you want, of course you can mention pollarding. I'm just telling you in a simple terms, you can present it better. Okay, so this, of course, the main thing is height. So this is around 2 to 3 meters above the ground, and this is nearly 30 centimeters. So one major difference is the height part of it. Okay, the first parameter that I've told you in terms of this, where exactly the cut is made. So that is going to be the first point of difference. One is 2 to 3 meters above the ground, and here is cut very close to the ground. Okay, so that is one example, right? Then the growth will happen. Okay, so you can talk about from where the growth happens. You can even talk about the purpose. Okay, so here the purposes for pollarding we've already seen, to prevent, or at least the grazing part you can mention, to prevent livestock from grazing, to control the tree height, and here right from the shoot, right, new shoots will come up, and here the growth is actually going to happen from the stump itself. Okay, here the purpose is the purpose that we just spoke about, that is what you can write. Okay, and similar is what you can write for Coppice also, that the main purpose is for preparing new shoots. Okay, whereas here the idea is to manage the height of the tree. And then of course last you can give examples like we've discussed. For Coppice also, some good Coppicers you can write. Okay, one example we have just seen. For example, Acacia, Catechu you can write, even Dalbergia, Sisu, etc. These are good Coppicers. For pollarding also we gave Salix, Hardwickia binata, okay, some Fraxinus, and the Tilia species can be written overall. Okay, so this is how you can attempt this particular question. Now, describe the different types of bamboo flowering. This also has been asked in certain ways in the exam, but here I've tried to ask you in a more comprehensive manner. Analyze the ecological implications of gregarious flowering on the bamboo forest. How does this phenomena affect forest ecosystems and local communities? It's a long question. So here also in these kind of questions, the emphasis that you should also bring is to address all the parts of the question. Okay, because again what can happen here, let's say you are not able to address all the parts, so that can be a problem overall. Fine. So here if we go about all the aspects of bamboo, right, and what kind of flowering is going to happen. So here types of bamboo flowering can be sporadic, it can be annual, plus it can be gregarious. The question basically is asking about gregarious, so don't think that only gregarious flowering happens. It can also be sporadic. Okay, it can be annual, it can be gregarious. Now annual, because it is very periodic in nature, every year this flowering has to happen, it has minimal ecological implications. Sporadic is something kind of spontaneous. Okay, sporadic flowering happens. This also, here it is more of irregular in nature, right, and here also ecological harm is overall, or implication is very limited. Here minimal, here I am saying limited. However, it is the gregarious part which is again an aspect of lot of curiosity amongst the different foresters, that why this happens, that why all of a sudden. Okay, so here in gregarious what happens, it is a synchronized flowering of the entire population of bamboos that happens exactly. Okay, so the main issue here as that synchronized flowering of entire, okay, population happens, and because of this, okay, if this happens, and by the way it occurs and it has massive impacts. And here it also happens over a large time scale. Now this has to happen annually, but this can happen ranging from even 20 years to 120 odd years. The point says that this happens at long intervals. Okay, so it has, I am saying it has a lot of economic, socio-economic and ecological consequences, which we'll now understand, right? Now if you see this, what are the implications? Now here I've mentioned both the implications on ecology and also on the community. We'll understand this. Okay, so on the forest ecosystem, when we analyze the implications, the vegetation is going to change because the flowering will happen very fast over a period of time. It's synchronized flowering, so vegetation changes happen. it impacts the soil also, okay. Plus, because of these things, the biodiversity will also shift to a certain extent, okay. So it is going to impact the soil, it is going to impact the biodiversity, it is also going to impact the vegetation, okay. So what happens here also, see, we have seen die off we just saw in case of sal forest. This is the massive die off for bamboo, okay. Because of this massive die off, the vegetation is bound to change, okay, and these are all the negative implications that will happen, okay. So massive die off is known as the gregarious flowering, okay. So massive die off, so of course the vegetation is going to change, right? Because see, when you see phenology, what you will see, when the leaf is shedding, when the leaf sheds, when the flowering happens, after flowering you have fruiting, and after then you have the germination. Here also what you will see, vegetation will change because of massive die off, so that is a problem that is going to happen, okay. And because of this, if the die off is happening, the canopy will also change. In fact, there will be a lot of gaps now in the canopy. However, a consequence of this gap can be that there can be certain other regenerations which can happen, okay. Of course, if soil is impacted, the biodiversity also gets impacted. So here are just a couple of points I'll tell you, okay. So what happens that here at least certain soil nutrients, okay, because the decomposition of bamboo will happen, so there can be some increase in soil nutrients, but there can also be erosion, okay, because of loss of the vegetative or the ground cover in this particular case, okay. What is the impact on wildlife? Because see, the biodiversity is going to shift, habitat is going to get fragmented, is going to get changed, okay, and the rodent population is going to increase, okay. So rodent population overall, because a lot of abundant bamboo seeds are here, okay, bamboo seeds will rapidly increase, and because of that rapid rodent reproduction is going to happen, okay. So that also is seen overall, okay. Similarly, the habitat alteration happens. Now this question asks you second aspect, impact on the forest ecosystem. You understand what is the impact on local communities, okay. So here, one second, right, the agriculture is going to be impacted, okay. So rodent population is increasing, rodent implication, this will attack the food crops, the crop destruction is happening, okay, and this has been seen in northeast, okay, the rodent plagues that have happened, especially let's say in case of Mizoram. So agriculture is impacted because of this, and because of this the food security is also impacted, because the communities which were relying on bamboo are going to face a problem, okay. So there can be a famine in this region, there can be a plague, there can be rodent infestation, and because of this the import and overall export value, the bamboo related products, everything is going to suffer, okay, because of a rapid decline in this case, okay. And because of this rapid drying off and die off, there is also a chance that the forest fire may also spread, okay, because of this, fine. So what you understand, types of bamboo flowering plus the implication this is going to have, okay. So keep this in mind, because this is again a question that can be asked. We've covered sal also, die off, we've also covered the bamboo flowering also through this question, okay. Next, how do ecophysiological factors influence the distribution of vegetation across altitudinal gradients in the Himalayas? In this question, I am expecting that you will draw a very simple diagram, okay, of how across when the altitudes change, okay, simple diagram of this sort you can draw, okay, and mention the species, okay, in those zones, fine. And here example of specific species, etc., and their adaptations to varying temperature and oxygen availability. Even if this was not explicit, we would have mentioned that yes, what are the different things that are done. Every year you will get different questions. Now in this very first paper I have given you question on arid and semi-arid regions, question on coastal for mangroves, coastal vegetation, question on Himalayan region. So whatever kind of question you can be expected in the exam, we have already covered it through in the first test itself, okay. Ecophysiological factors, how do they influence the distribution? Here also very simple, think about the various climatic factors, okay, altitude factors. So in very brief, what we can say, for example, temperature. we know something like a normal lapse rate. So what is that? For example, we say as you increase the altitude, the temperature decreases. Okay, so here approximately 6.5 degree Celsius for every 1 kilometer, that is for every 1000 meter. Okay, now because of that temperature change, you see right from, let's say this is the 0 meter, as we move up the temperature is going to decrease. So right from tropical, subtropical, okay, as we move up temperate, coniferous, okay, alpine, that is how the change is going to happen. That is the first. Second, oxygen availability is also a big problem. So there is lower oxygen at higher altitudes, okay, and this is going to, if there is lower oxygen, again think about respiration, think about growth, think about photosynthesis, etc. Okay, this will also be, plus precipitation and moisture. In fact, precipitation and moisture can be written as separate points also. Okay, so this precipitation patterns is going to vary with altitude. So soil moisture, this can be also either seen in the edaphic part, because remember how we had done the cold deserts. In cold deserts we had seen vegetation and biodiversity, all these things are getting impacted. Okay, so if the precipitation is less, the moisture availability is less, snow cover is there, cloud cover is there, you will have some other issues, right? Snow can be mentioned as a separate point also if you want. For example, snow is very important for in the process of natural regeneration of Cedrus deodara. Okay, this is one. This is an diagram you have to draw in this exam. Okay, again this is something basic for each of the part. Even if you write down one example, I'll be more than happy to see that. Fine. So for example, you in the tropical part, etc., you can give examples. Subtropical, for example, sal, shore robusta, you can say. Okay, cheer pine, Pinus roxburghi, you can tell. Rhododendron species or oak species you can mention. Okay, fir, spruce, any of the example you can take up. Rhododendrons in the meadows or the higher reaches. So that is this is how you will also cover up some space. This is the first part, second part. Okay, and then we'll talk about the adaptations. Now adaptations can be both for temperature and also for oxygen. Okay, now here there can be frost tolerance, which can be seen. Okay, there can be reduced transpiration, shorter growing season, because if the growing season is going to be longer and if it is being subject to very harsh conditions, that is also a problem. By the way, because of climate change also we are seeing, especially let's say if I give the example of rhododendrons, the phenology or the overall season for growing season is becoming shorter. This is also one of the temperature adaptations. So shorter growing seasons, reduced transpiration, so that you overcome, you lose less of water, and lastly is you are able to manage or hold frost better. Fine. So frost tolerance, etc. Okay, and again for frost tolerance, etc., there are specialized proteins. There is lesser water content in the internal cell, etc. Okay, and there is a separate topic that you also read, frost. How does frost impact regeneration? Okay, so again borrowing from that. For oxygen adaptation, low metabolic rates. Okay, in fact if you have read about dormancy, okay, so overall one of the best ways is to reduce the metabolic rate, which means reduced availability for oxygen, right? Photosynthetic efficiency has to be better, so again linked with the part of reduced transpiration. Okay, opening and closing of some stomata to be regulated, right? Plus stunted growth or dwarfism, which will also utilize limited oxygen. Okay, so these are also certain examples that we are generally seeing in these particular cases. Okay, for example, for frost, transpiration, shorter growing seasons, etc., this is how 3 points each, whatever, at least 1 or 2 points if you remember, that will help you better structure your answers here. Okay, so that is one. Then this is a question that is very straightforward. Why is grading of nursery seedlings crucial for success of forest plantations, and how does it impact overall plantation performance? Okay, now just think about it. Grading, even if you don't know much, grading of anything, let's say you are grading certain food products. Okay, certain food products are of highest quality, they can be exported to Europe, If they're of low quality, they will not be exported. Okay, think about the MDH masala and all the controversies. So grading matters. If we have grade A seed, grade B seed, grade C seed, okay, so grade A seed or the grading part of it will be the best. Okay, so the question says why is the grading is important, it's crucial for success, and how does it impact the overall plantation performance? Two parts are there. Okay, so here we'll talk about both the parts, how does it impact, plus the basic part here. Okay, so here the first part, nursery seedling grading. Why? What is the process of categorizing young plants? We know seed, seedling, sapling, okay, the whole part, and then of course pole. So nursery seedling grading is a process. You're categorizing the plants based on their quality, physical characteristics, okay, before they are transplanted to the field. Two keywords, quality and physical characteristics. Okay, what is the primary purpose? To ensure healthiest, use this keyword, and the most vigorous seedlings are used in forest plantations. Okay, what is the importance of grading? It helps overall, promotes uniform growth. Okay, better resource optimization can happen because of grading. Improved quality of timber, will get superior quality, etc. Okay, and enhanced survival rate. Higher survival rate will also be seen in this particular case. Okay, that is something to understand, right? Now, what is the impact on plantation performance? Okay, same thing. When we go for initial establishment, okay, and here also if we plant it or see it over a piece of year, let's say if we talk about Tectona grandis, okay, plantations, if we go with the highest graded seeds versus medium seeds or low seeds, the highest seeds, graded seeds, they will be having higher survival rates, and in the very first year, in the most, let's say, young phase, a high survivability is a very important factor, otherwise they will die off. Okay, they will be perished. So because of higher survival rate, it is important in the initial establishment. Okay, then there is a reduced need for replacements. You don't want enough now replacements, so overall it is better, right? Growth rate, so growth rate is faster and growth rate is more uniform because of this. So this also helps, and this is also one of the importance, that it helps you in uniform growth, right? Timber quality, because of, we also saw improved timber quality. How? Because of the improved stem form in better grading. Okay, the stem form is better, so you will get better timber quality, which simply means you will have higher economic return, more price you will get in the market. If there is more defects, abnormalities, if the stem form is not very uniform, the price will be low. Okay, so directly this is a benefit. And overall, if there is a higher superior species quality overall, it will be better in carbon sequestration, it will be better in nutrient management, soil management, etc. So you will get a lot of benefits across. Okay, in fact, in this question also, if you want, you can give an example of how, for example, if we take different seedlings based on the different grades, the ones with the higher let's say part, the higher gradings, they perform almost 30 to 40% better. Okay, that had been seen overall, right? So that is one part you can talk about in this particular case. Fine. Okay, now I hope till now you have been able to address. Now let us talk about the other portions. Explain briefly, so we now move to the section B here. Explain briefly the factors that determine the selection of a silvicultural system. Okay, now here also the parts which are self-explanatory, you can go through them. I'll just explain what is to be understood and known here. Okay, so here, for example, if we talk about, so yes, around 10 points are there. You may not need to remember all of them, just have the points are more or less self-explanatory. The question simply says, if you have to go for a simple silvicultural system, clear felling system, it can be a selection system, it can be a shelter wood, any system. If I have to choose a system, on which factors would it be? Okay, so here just what is the species characteristics. Okay, so conifers are not suitable for coppice. For example, I told you they are not good coppicers, and in these questions, example are your, let's say, parts which will differentiate. Fine. Similarly, light demanding trees are better suited for clear felling. So these are the parts you should underline and write down. If you know this, the species characteristics, then you will choose appropriate silvicultural system. Okay, so conifers are not suitable for coppice, for example, and light demanding trees may be better suited for clear felling or shelter wood. That is one example. That is species characteristics. We can go for site conditions. Okay, so soil type, climate, topography, hydrology, etc. What is this? Site factors here. Remember, site quality, site factors, all of that is what? Climatic, edaphic, topographic, biotic. Whenever we say site conditions, remember this only. Okay. Now, clear felling should be avoided in areas which are prone to soil erosions. These single examples is what I want you to write down separately. Okay. So, clear felling should be avoided. Okay, I understand. Now, what is the objective of the management? They may want to increase the revenue, they may want to do a protection, whatever they want. So, for example, if the desired outcome is timber production or biodiversity conservation or aesthetic value, depending on that, we will choose a silvicultural system. Okay, so what is the objective we want? Environmental conditions. Okay, which means soil or climate, do we want to preserve only that? Resistance to external dangers. Okay, biodiversity conservation, this can also be a factor. Okay, economic factors can also be one. Okay, so again, the quantity or quality of the produce, right? Returns, what is the price in the market, the fluctuations, that can be there. Regeneration method. Okay, how safe it is, how simple it is, how many times can that be done, this is also an important factor. What is the existing stand, what is the condition? Okay, so here, do we want even aged, do we want uneven aged? Okay, so here, what is the composition of species, age structure? Even the existing stand conditions will also be part here. Now, these two parts of wildlife needs and environmental, you can club it into biotic part here. Okay, so here, if we choose any of the system, it will create a different kind of a habitat. Okay, so again, it is up to us to see which is crucial for wildlife management. Okay, logging conditions, how easily can you cut and extract timber? You can also link logging conditions to economic factors also. And last, very important part is long term planning. Okay, so wherever if possible, and you'll see more of these points in paper 2A also. Long term planning, okay, management objectives, site conditions. Okay, but again, this will give you a lot of points on how to write this simple question. Okay, so I hope by now you have been able to understand how to attempt a question like this, right? So I hope this part is clear to you, right? Now let us talk about the next particular part here in this particular case. Okay, and now we will have we'll talk about one second, yes, the silviculture of Dalbergia sissu. Okay, now see, one question based on silviculture we've already seen, right? So now let us have a look at the other part. Okay, so here, whenever you get a question, okay, there are some basic things you can write in silviculture. Like for example, here they are simply asking you the silviculture. So here you can talk about the common name. If possible, you can even mention the family name. In addition to this, okay, like we saw in the previous question, we can talk about the phenology. We can talk about the silviculture characteristics and even the modes of regeneration, right? This we can write about in this manner. So we are basically talking about shisham. Now, while other facts you can just definitely understand and read about, just a couple of things I'll again tell you, but the more you do it again and again. So here what we'll talk about: leaf fall, flowering, fruiting, and the last part that is related to germination. Then silvicultural characteristics, right from we'll talk about soil in terms of light, okay, ability to coppice, maybe related to fire, etc. So there are certain attributes that we'll have a look at. So the very first thing is that first of all, we don't know how to answer these questions. So you'll get to know regeneration, how it is done naturally, how artificially. At least this part you should know. Additionally, if you have more space, Okay, in the end you can also talk about overall the economic benefits of Dalbergia Sisu. Now economic benefits you all know how to write it, right from timber. Okay, right from, because we've already seen how to structure that, how is it used for fuel wood, medicinal uses, export, etc. 4 or 5 points you can write if you have more space left. But I think even if you write all these things, that is fine. Even if you have some space, in the end you can even write on challenges in the silviculture of Dalbergia Sisu or challenges in the silviculture of X. Let's say if the question is of 20 marks and we have to have more space to write. Okay, the point is you should know what headings are there. Okay, so last maybe the challenges, and then overall you can just conclude. So that is how you can structure your answer in this particular part. So again, you should know what is the framework of how to write it, and then of course you can address this particular part here. Okay, now what is to be known? Dalbergia Sisu Shisham, it's a deciduous tree. If it's a deciduous tree, it will have a particular time for leaf fall. This will generally be around dry conditions, again to conserve water. Okay, so here just a couple of things I'll tell you. So here it's the leaf falls during the dry season, roughly from January to March. This is the leaf fall. Okay, flowering happens now. Generally the flowering will happen before the monsoon. Okay, so flowering here also happens from March to April. Okay, from March to April this happens. Fruiting here happens. Okay, the fruits, they will ripen. This will happen around from October to December, right? And the germination, this simply happens around the monsoon. So almost similar to what we had seen in Acacia catechu. These are the things. That was also deciduous. Of course it was found in more drought prone or drought hardy conditions, right? But this is also deciduous. So similar format you will find in phenology. That is why even if 1 month here or there happens, it is not a big problem. Fine, you have to understand how this is to be structured. Then silvicultural characteristics. Okay, so few things I'll tell you. It's a fast growing or a moderately fast growing species. Okay, excellent copicer. Okay, it has the ability for drought tolerance, Okay, this can also be mentioned here. Other than that, you can talk about frost sensitivity also. Okay, that young seedlings are sensitive to frost. Other than that, of course, Dalbergia Sisu is found around in which regions? So it is found around 900 meters elevation. So slightly around certain altitude you find it. Of course, you can also find it in around 1500 meters of Himalayas. Okay. If there is excess soil moisture, if it is too much waterlogged, it is also prone to root diseases. Okay. So again, these are few things that one has to understand in this particular case of how to attempt and how to write this. Okay. In terms of regeneration, right? So here, of course, natural regeneration will happen through seeds. That is something we generally read about. Here also, the seed propagation can happen artificially. Okay. Similarly, through nursery planting can happen, and artificial regeneration can also happen through vegetative propagation. Right. So this is again how you can talk and write about this. Okay. Right. Other parts you can also read from the model answer, but I think this is more or less certain of how to structure it. Economic benefits also we have understood, and of course there will be challenges like, for example, if there is waterlogged, if there is a lot of waterlogged soil, if light is not available properly. Okay. In all these things, the problems can arise in the silviculture of Dalbergia Sisu. Okay. Now discuss the physiological adaptations of plants to survive in extreme temperatures, providing examples from arid and semi-arid regions of India. Okay. Here there are many examples that you should know, and by now you have to try to put them exactly, you have to remember them. We have deep root systems. Okay. Now, why there are deep root systems to access soil or water? This can be seen in Prosopis juliflora. Simple one line, 1 point, one example. CAM photosynthesis, right? So generally there is C4 or C3 photosynthesis. CAM photosynthesis is a more optimized photosynthesis, right? Here there is less use of water, optimizing for water loss, etc. It is seen in the prickly pear cactus, that is also known as Optunia. Okay. Then there is also succulents. Okay, that is also seen. So in terms of thick stem, okay, this is generally seen. This also overall helps. Reduced leaf area and leaf modifications. So again we can mention acacia species. So if the leaf area is reduced, this also helps. Leaf modification, it can be thorns instead of leaves. Okay, this also is helped. Sunken stomata can be seen in Calotropis procera. A sunken stomata you also see in, by the way, in case of mangroves also. Okay, so this is also a great way to conserve water and only shed it only in specific times. Plus dormancy. See, dormancy generally also we see it in very extremes of conditions. High conditions here also, in cold conditions also dormancy is there. Okay, that also helps the plant to survive. So we've seen around 4 examples of species and around 6 points. These can be more than enough to write an answer. So these are the physiological adaptations that are helping the plant to survive. Okay, in this, if you want, you can draw a simple diagram like a cactus, wherein you can show the deep, the root systems. Okay, you can show the thick stems. Okay, the succulent or the thick stems. You can show, by the way, I can even add waxy leaves. Okay, thorns instead of leaves. So a diagram plus all these points, around 4 or 5 points in a diagram, plus this explained through the name of species is enough to fetch you the maximum marks in this question. Okay. Now write the phenology of the following. Again, this is an example we will have a look at. Now the question is phenology. Phenology is the calendar when the leaf will. Again, 4 things you have to know. Okay, right from the leaf fall to flowering to fruiting to germination. Now questions like this you may wonder how to write it. Again, if you are able to demarcate into deciduous and evergreen, your job will become easier. Okay, because in deciduous there will be, especially in the dry seasons, the leaf fall will happen. Okay, the flowering will happen around the time of leaf fall. Okay, but again to conserve water, and then the germination will happen in the monsoon. Okay, and fruiting around that time or even around the October to December part. This is generally a trend that is seen. Okay, so instead of ratifying all the 3 things again and again, if you are able to segregate deciduous and evergreen, you can make your life easier. Okay, here also these chirpine, okay, or the deodar trees, these are example of evergreen, whereas let's say teak and sal, these are example of deciduous ones. Okay, so based on that, again you can go through the phenology. Again, this is a part, this is slightly more factual in nature, you can again have a look at. Fine, so you can understand. So here both, again I've told you, Tectona grandis and Shorea robusta, they will follow a deciduous pattern wherein the shedding of leaves will happen in the dry season and flowering will happen just almost when the monsoon is supposed to arrive. So just around that time, during between the dry and the monsoon part, this will happen. Okay, chirp pine and deodar, these are evergreen trees. Okay, so they will flower before also, they can flower, and they can flower after the monsoon also, plus they will have a longer fruiting cycle. That is what is generally seen. Okay, so that is a takeaway for us. For example, if I just give you one example, Tectona grandis, the fruiting for Tectona grandis happens from October to December. Okay, that is one part that we generally see. However, in case of let's say deodar, Cedrus deodara, the seeds, it is around October to November. Okay, so almost similar time that you see, right? Similarly, if you go for let's say Pinus roxburghi, so instead of October, it starts from November. So you will find almost a certain pattern here, not exact pattern, but again my point is you will be served better when you understand the difference here, deciduous and evergreen, and then just these 4 components. Okay, just go through this part here once, you will be able to address this better, right?
Okay, now what is improvement felling and how does it contribute to forest management, and analyze whether improvement felling can be classified as a silvicultural systems, and you have to provide reasons for our argument in this particular manner. Okay, now here also, if when you see this question, there are few things. First we have to define what is improvement felling. Okay, so it is basically a silvicultural practice, yes, which involves selective removal of undesirable or lower quality trees, okay, from the forest stand to improve the overall quality or growth of the remaining parts. Okay, so main thing what is happening here, you are removing the undesirable or low quality trees, okay, to improve the overall quality. And this basic definition is going to come very handy when we see whether it is a appropriate silvicultural system or not. Okay, objective is healthiest, most vigorous trees. Why? You want to reduce the competition, you want to enhance the access to light, water and nutrients. Okay, that is going to happen here. Now what is the contribution to forest management? Better timber quality, this is economic angle. Reduces the risk, this also can be linked to economic, so more viable production is there. Okay, maintains biodiversity, ecological viewpoint, increased ecological functioning. So all these are the ways in which it contributes to a better forest management. Okay, so that is again something that we can talk about in this particular manner. Okay, now however, if we were to again give certain examples of what is the issue, okay, so why do we not say that this is the reasons why it is not a silvicultural system? Okay, so the very first point is there is focus only on stand improvement. In silvicultural system, the entire cycle, okay, so entire regeneration is taken into account, whereas improvement felling only focuses on a very small aspect that is only related to the improvement of stand quality. Okay, second, I'll just rephrase what I said here. There is a lack of focus on regeneration. Okay, that is also a part, right? Then it is again a short term mechanism, whereas the silviculture system is a very long term, entire life cycle is taken into account. Okay, plus it is going to apply to existing stands, no talk about the new stands, etc. So because of these four major reasons, you do not classify improvement felling as a silvicultural system, although when you see that you may be considering that this may be a silviculture system, but it is not. Why? Because it is focusing on stand improvement, it is not focusing on the entire regeneration, it is very short term, and it is focusing on existing stands, whereas silviculture systems is focusing on entire process, it is long term in nature, it focuses on both the existing as well as the new stands. In fact, when it talks about entire life cycle, it will talk about both these things, right? So that is why, and this question has been many a times repeated, so keep a note of this, of how would you be able to write this particular part here. Okay, so that is one. Okay, now let's talk about question number, the next question, that is question 6a. Now see, from question 6 onwards there are certain questions. Now this is more related to silvicultural systems, right? So here, at least the very first question is a very basic question on silviculture systems. Here I would again encourage, of course, one, you have to write down the definition of what silviculture system is, and then you have to draw the diagram, okay, wherein you talk about the high forest, the Coppice forest. Within high forest we then move into, let's say, the clear felling system, the shelter wood system. So that is the kind of expectation that we have, and if you understand that diagram well, you will be able to then right from the very let's say outset, you will be able to understand a lot of these questions well. Okay, so here in this question, of course, what you have to do, you have to give the definition of silviculture system. Okay, and second, you have to in this mode of regeneration and respond to the felling patterns. It would be better if you give a basic, let's say, classification. Let's say the silvicultural systems are first divided into these high forests. We know how high forests, which are directly regenerated through seeds, and then you have these Coppice forests. Okay, and a very simple classification here. You can go into these three mechanisms, and in this part here we can talk about. By the way, in this test we've asked you certain questions which will help you understand this particular part well. Clear felling system, for example, we can say shelterwood system, and try to have a practice to make this. For example, when I say Coppice forests, so Coppice forests, when you are also Coppice with standards, Coppice with reserves, even pollarding, all of that becomes an important part that you also read about. Okay, so here if you have seen the basic diagram here, so this is a system of concentrated regeneration. So the question itself says that it talks about how they are, let's say, segregated in terms of regeneration. So in terms of system of concentrated regeneration, you have clear felling and you have these the shelter wood systems. Okay, and clear felling is also then divided into three more systems: the clear felling system, then you also have the clear strip system where you have some alternate strips, and you also have the alternate strip system. Try to draw this once. Shelter wood, you have around 7 types. Okay, or sorry, 8 types: uniform, group, shelter wood, strip, Wagner. Okay, so again just have a no here. So this is system of concentrated regeneration. There is a system of diffused regeneration, which is then also divided into certain aspects, which has selection system and the group selection system. Okay, and then you have the accessory system. Maximum questions which have come in the exam are related to these two, which we'll be discussing very shortly. Okay, so this is one. Accessory can be 2-storied. Okay, high forest with reserve system, and here also you see something known as improvement felling. Okay, and then in Coppice I've already told you. So one is the simple Coppice system. This Coppice system with standards, with reserves, okay, with Coppice with 2 rotations, the 2 rotation system, which is almost very similar to this standard part here. Then the pollarding, okay, and then the shelter wood Coppice system. Okay, so this is how we will talk about the whole aspect here, and this is again something you can know. This is what you have to overall talk about. So give a good definition of silviculture systems and detail the classification that can be based on mode of regeneration and the pattern of felling which is going to be there. So try to draw this a couple of times, you will get better at it over a period of time. High forest, Coppice forest, system of concentrated regeneration, clear felling system, shelter wood system, which is again then divided into its own systems, diffuse systems, accessory systems. Okay, then of course the Coppice systems and their parts. Again, of course, we know we've had a question on improvement felling, which is by the way not a silvicultural system. We will see a question on CFS and shelter wood. We'll also see questions on selection systems. We'll also see questions on these two. So this is a very good revision of how to cover this part of silvicultural systems. Okay. Now moving on. Second part here, discuss the various methods of vegetative reproduction used in forestry. Okay, highlighting their advantages and disadvantages. How do these methods contribute to sustainable forest management? Okay, so very first part you have to explain what is, you can just give one line: vegetative reproduction. Okay, and then of course we can talk about the different methods of vegetative reproduction, and here also very simple diagram like this can be useful. You can talk about cutting, grafting, layering, and micro propagation, that is also known as tissue culture. Okay, so these are the various methods of vegetative propagation. Okay, Now in this part, of course, you have to give examples and parts for each of them. So a couple of things I'll tell you. Otherwise, this is more or less self-explanatory. You can also just go through the model answer here. But just for the sake of our own understanding, we'll just have a look at some of the portions, okay, that one also needs to know. Okay, for example, if we talk about the cutting, okay, so cutting can be related to root. The root cutting we can use, cuttings of the stem, etc. can be used, okay, or the leaf, okay. Now the simple advantage here is it is of course simple, it is cost effective, okay, that is there, okay, plus it can be used very rapidly. But the con here is it is not suitable for all the species, okay. So not for all I am writing, that is a disadvantage for cutting, okay. Other than that, certain species may require more specializations. Here also the cutting may not be very appropriate, okay. Plus, for example, if a species already has a disease, okay, this cutting can lead to disease transmission. This is a negative here, okay. Same part, grafting also, right. Of course you would have seen these things in more detail. Now in these aspects of discussion, I'm just going through just this in overall wide view, okay. So for grafting, you know, we can use graft, okay. So for grafts there are two things, one is known as your scion and one is the rootstock. These two things are going to be clubbed together, that is the grafting, okay. So in these two parts, whatever are the desirable traits, we will take it up and combine it, that is the best part, okay. So specifically the parts wherein root cutting etc is difficult, we go for grafting, okay. So that is one, so that is another alternative that you get, okay. However, here also there are certain challenges, okay. The number one challenges of course will be, because see, this is simple, this is going to be very a lot of skill plus labor intensive, because grafting will not be very easy, it may fail if it is not done in a technical manner, okay. Plus it will be more cost effective, more cost as compared to cutting. Cutting is fairly very easy, we have seen so many simple cuttings throughout, okay, be it rows etc, we just use a cut and that can be used, okay. So that is again a part, okay. Now in layering, what we are doing, you are creating another layer, okay. So simply, let's say if there is a stem, on that even a root kind of a layer can be put on an additionally existing plant variety. So from that also the growth can happen, and this layering has been successful. Layering can happen also in various ways, I'm not going into too much detail here, but of course layering has seen certain success, okay. And here also things which are difficult to be cut or grafted can also be done via layering, so that is there. Plus as compared to grafting, this is very minimal in nature. These are all the positives that layering offers, okay. But here also it is time consuming. Second thing is layering cannot be done at a mass rapid scale, okay. Layering cannot be carried out at a mass scale, that is also a negative. And the last thing is micro propagation. So here we can talk about tissue culture, okay. So micro propagation, so here if we want a rapid multiplication of superior species, let's say I say elite genotypes, so for multiplication of these elite genotypes we can do so, okay, yes. So that can happen here, okay. Plus this can also lead to disease free plants, because you are doing micro propagation, this is going to be very much technical in nature, intensive. We can go for superior strands, disease free plants, elite genotypes. Use these keywords in your answer, use these kind of simple diagrams, that will overall help you, okay. And for this the issue is high initial investment, the setup cost is high money wise, plus you can understand this will require a lot of skills, highly specialized in nature, very much skill oriented, okay. So these are some of the issues that are there. Now how do these methods contribute to sustainable forest management? You can create points based on this, okay. Help in creation of superior genotypes, better productivity, healthier stands, okay. So if there is more productivity, there is better yield, that is overall going to be helpful. Okay, helps in pest and disease control. All these points will be the last part of this question that you can also highlight. Okay, that how does this contribute to sustainable forest management. Okay, now what is the difference between Coppice with standards and Coppice with reserves? Okay, first of all, I'll give you very basic understanding about this. Okay, and then of course we'll talk about what is to be understood here. See, generally we have seen, for example, if this is a tree, okay, somewhere around here, around 20 to 30 centimeter above the ground is here. This is how the coppicing is done. Fine. Now please note, and if you understand these terms, you will get, one is coppice with standards and one is coppice with reserves. Okay, in standards what will happen, you will have proper, so one, you can think this as you are doing creating layers. So you are creating coppices, but you will also have proper matured proper trees associated. In standards, your basic objective is both. You will cut them, you will go for regeneration, but these standards, see, standard is something which is of good quality, good variety. Okay, standard will help you maximize the timber production. So economic yield will be high. These are superior, good. So some things, some tree varieties you will not, let's say, harm or touch, whereas the other ones we will put a cut or the coppice. A simple coppice is simply where you have all the coppices, okay, which will regenerate over a period of time. But this will take a long time. Okay, so this will not be economically very much viable. This you can cut it for economic value, and this of course will regenerate over a period of time. So standard is used, first it is of good quality, it will help you maximize the timber production. Whereas when you are saying reserves, remember these are low height trees first of all. Then why do you have them if they are low height? So for example, if I were to draw this, no, this was the coppice, here it will be a very small tree as opposed to this. If you want to draw comparison, this is going to be useful for ecological benefits. Okay, so here maybe some of the seeds fall down and the regeneration will start. Purely from an ecological point of view, you are having them. Remember this, that's the main point of difference. If you understand this one point, other points will be following from that. Okay, so coppice with standards, it is from an economic perspective, wherein this particular large or let's say mature stand is used for, let's say, getting or the timber produce. Whereas the coppice remains, here also the coppice remains, but you use, let's say, an overall inferior tree or let's say a tree of a lower height, which is purely from an ecological standpoint. Okay, if this part is clear, then we can go into what is the difference between the two. Okay, so now if I were to tell you about the difference, okay, so the very first thing is in coppice with standards, okay, it is almost a two standard, okay, or almost a two system. On one side you have mature stands and one you have this coppice. Okay, here you have these low height. So one is the definition, other is the objective. Objective here can be to maximize economic yield or timber production, alongside the regeneration, here also regeneration, but here for ecological purposes. Okay, okay, so two standards, no, I should have written two layered structure. Okay, this is a single layered structure, this is a two layered structure, creates mature stands, two layered structures and creates mature stands. Okay, so you have a regular coppice plus mature stands, and the reserves are again scattered. You have some scattered reserves, so you understand reserves. Whereas this is a standard. Think from a cricket team, you have a standard player and you have something as a reserve. Although there you may use the reserve almost for the same thing, but here it is different. Okay, reserve, okay, is different here. Okay, so here one line, reserves are typically smaller, left for ecological or just regeneration purposes. ecological or regeneration purposes. Okay. Now these reserves are not much managed. Here they are managed for maximization of yield, for proper harvest. Okay. So here the overall goal of the management can be, or if I say the management goal, so here one line we can say production of small wood we will get from Coppice, plus large timber we will get from standards. This is large timber you will get from standards. So now you will understand very simply, plus small wood from Coppice. Okay, this is how you can attempt to mention this. Whereas here the focus is only on the small wood that you will get from Coppice. Other trees, because they are only left for regeneration or for the ecological purposes, that's it. Okay, so here example you can take about of oak hazel combination. Here you can give example of scattered birch trees. Okay, so that is how you can understand the difference between Coppice with standard. That is why I basically told you, if you want you can also draw a diagram to explain that. Okay, and this again follows with our understanding of this silviculture systems, high forests, Coppice forest. Coppice may you have simple, Coppice with standards, Coppice with reserves. That is how you can understand this whole part. Okay, all right. Now this question, fairly straightforward question. Define, you have to define, tell different types of succession. Okay, give examples and talk about the different theories for succession. So there are different parts to this question. So number one part is the definition. You have to define the part. Okay, then we have to talk about different types of succession. Okay, in the definition you can basically say that the overall succession basically talks about, or when we say ecological succession, it tells us about how from the very basic, from let's say the barren rock or a land to a final climax community. Okay, the whole stage or the process which happens throughout the movement of vegetation chronologically, that whole process is defined as succession. Okay, so we'll give a very simple definition. Okay, that from a pioneer community to the climax community or the climax stage is this whole part of succession. Okay, again this is a topic that we generally read. I'll only give you the basic skeleton here, the different types of succession, etc. So here you can talk about if the vegetation is present, so you can talk about primary and secondary succession, one. Okay, similarly this can be autotrophic, this can also be heterotrophic. Okay, you can also talk about hydrarch, mesarch, xerarch. Okay, this is more important, this is primary and secondary. So the different types of succession also we can talk about, and of course you can explain them. Here I'm just giving you the overall skeleton here, and what are the various theories of succession. Okay, so here also if you can mention the different theories of succession. Okay, the monoclimax theory, the polyclimax theory, the theory which is again related to information. Now here just one by one I'll tell you. For example, if I talk about the monoclimax theory, this theory basically talks about how succession that happens. Okay, there can only be one cause related to it. Okay, the name mono directly will tell you that yes, this is only related to one particular part. Okay, so here of course what you are going to understand in mono succession theory is that there is only one particular part okay, which is directly going to be a cause. Now this monoclimax theory was changed by the polyclimax theory. Now the polyclimax theory will tell us that there can be more than one cause associated, okay. So basically when we talk about the polyclimax theory, we can talk about how more than one of these attributes can be linked, and we can of course understand this, okay, in proper detail here. That is the polyclimax theory, which basically tells that there can be more than one. The information theory is slightly different, which basically will tell you that that overall the changes that happen, right, that here in this the information that is supposed to be happening, okay. So here just remember that succession is just a function of energy balance and nutrient cycling, okay. I'll just write down, because these two are self-explanatory. Mono means single, which basically will highlight, okay, single climax. Here just overall, multiple by mean multiple causes can be there, but still climax would be one. And this was finally changed by this climax theory, okay. So here climax is a function or overall related to energy flow and nutrient cycling. And the last part here is the climax pattern hypothesis. Okay, which basically will say that there are different patterns that are available depending on different ecosystems. There will be different climaxes that are possible, which is the most advanced theory that we see overall, okay. Monoclimax, polyclimax, information, and climax pattern hypothesis is how we talk about. So again, this is what you understand the basic details. Again, you can go through the model answer once to get this better understanding here, okay. So that is one. Then a basic question on what are tending operations and enumerate the different types of tending operations, right. So this is directly a very factual question. You will talk about what are the various tending operations, which again help in basic stand management, in the canopy management, overall silvicultural operations, right from cleaning, okay, weeding, pruning, thinning, even for example we can say improvement felling, I can even add a couple more, but basically the question is all these are the common type of tending operations that are there. Now within this more questions have come on these two. By the way, these two we've already covered here, okay. Again, I would encourage you to read more about different types of thinning operations, okay. For example, we had seen thinning from above, thinning from below, mechanical thinning, free thinning. Again, there are different names to it, etc. We can read about it. For improvement felling also we've seen, but again you get the basic idea. These cleaning operations, weeding, pruning, tending, all these are subset of, these are all tending operations, and these are also of course very much important for ensuring proper canopy management, proper stand management, and how these things are overall carried out. Fine. So here of course you should know what are they define them easily. This is again a straightforward question, but of course it is question 7B. If you don't know A or C, perhaps you may not have even attempted it, right. So again you can go through this one, not a very difficult question. Now compare and contrast clear felling and shelter wood silvicultural system. So again, first of all we'll understand what these are, and then we'll see how can you attempt this overall. Now remember, clear felling, name is clear felling. In a simple clear felling systems, you will cut all the trees whatever is present in one go, okay. So you will cut everything. So for example, if there are almost a lot of forests like this in clear felling, in the first stage, now these are let's say the periodic blocks, you are left with none. Again after some years the growth will happen. So here you will cut all of them. Because of that, it is going to promote even aged growth. Shelter wood system is slightly different, okay. It will, here you will again go for first more stands, more mature stands are first taken into account. So here it is not a uniform cut that is happening throughout, fine. And because of this, there's a slight difference that happens, and because of that, the canopy will be different. Okay, the management will be different, the operations will also differ, right? So here, to understand this, in one line, all trees are removed in a single operation in clear felling systems, which leads to an even age stand, whereas please note gradual removal of mature stands. So as and when the stands get matured, you are going to remove it in a shelter wood system. That is why I'm using the term relatively even stand. I'm not saying even stand total. Okay, although you also have some, let's say, selection system which will promote an uneven stand. Okay, so even stand can also be there, uneven stand can also be there. So here the shelter wood systems, gradual removal of mature stands which will lead to relatively even stands. That is the, if you understand this basic crux, then we can build on this. Okay, so here a couple of points I'll just overall tell you that what happens because of this. Okay, so here few points, and these are the proper crux that you should know. Now if you understand this, and now when you have to write down, okay, the differences, I'm just telling you the parameters on the based on differences. Okay, the very first parameter that I'll tell you is related to the canopy. Okay, now the canopy removal will be in clear felling systems all at once. Okay, whereas in the shelter wood systems it will be gradual. I'll write down all the points, you should also write down with me, and after the lecture also try to see, okay, for CFS clear felling systems what should be the answer, for shelter wood what should be the answer. Okay, canopy removal, okay, one. Second is the regeneration environment. Okay, now in clear felling systems there are open conditions for regeneration. Okay, whereas in the shelter wood systems, because see, in you cut all things at one go, everything is open, whereas here there is a gradual removal. Okay, so because of that there is a moderate, or you can say the microclimate that is available for regeneration is not entirely open. Okay, that is the second part. Okay, the regeneration environment is modified in the case of shelter wood system. Okay, now third point is very important, which species are suitable. So the light demanders, the light demanding species, okay, for that clear felling system is better. For light demanders, clear felling system is better, whereas if we want to have both light demanders as well as some moderately shade tolerant also, we'll go for shelter wood system. So it is accommodative even of the shade tolerant species as well. Okay, then if with respect to soil protection, now you have cut all the trees in one go, soil is prone to erosion, right? So clear felling system does not offer enough soil protection, but shelter wood offers, because the gradual removal is there. Okay, so shelter wood system offers better soil protection, and this you can easily of course understand, because here at one go in clear felling systems all the trees will be wiped out. Here you are doing it in a gradual manner. Okay, so soil protection is better in shelter wood. In terms of aesthetics or visibility, of course, if we go to a clear felling system, if there is a total barren or a deserted land, because all trees are cut down, it does not look good to the eye, right? Whereas in a shelter wood system, because there is a gradual removal, there is a proper canopy management, it is also better looking to the eye. Okay, last part, operational complexity. Okay, so of course clear felling systems, anybody can come, you cut down all the forests, not very difficult. It in fact is very easier to execute, whereas the other part, it requires a lot of finesse. Okay, so it is this system that requires, shelter wood requires more skilled, better management. That is one basic part that you will or we will get to understand. Okay, so that is one. Okay, so I hope these are the basic differences that are very clear to you. Again, this is a very basic part, But if you understand what the core system is, then you will be easily be able to write down the points, okay, for these, let's say, particular dimensions. Okay, then question, what are the different question number 8a, what are the challenges and strategies involved in the rehabilitation of degraded mangrove formations? Okay, first of all, we'll see what are the challenges. We'll also understand strategies and 5 key mangrove species that play a crucial role in such rehabilitation efforts. Okay, here also we have seen almost 5 different species. Okay, Avicennia, Sonertia. Okay, we have seen Rhizophora mucronata. Okay, so 3 we already know, and 2 more I'll tell you. Okay, we can even add Brugueria species. So these will always be very handy. Now imagine restoration or rehabilitation of degraded mangroves. If it is happening, why will it happen? Okay, so it will happen because of waterlogged conditions, which means hydrological challenges, salinity haline formations, or excess water salinity. Okay, even I can add the issues of soil, waterlogged soil, etc. So water is a separate part also, I can take it, and along with soil also, the soil deficient in nutrients, which also is a issue. The soil may also have excess salt within that. Okay, so soil nutrient balance is also a challenge. Okay, then another challenge is the loss of biodiversity that happens in these regions, because these regions are already degraded. Okay, and when you go for these areas, it is very difficult to execute these parts. Okay, then let's say the water levels may not be very appropriate to go for rehabilitation. That is why we go for raised bed or canal plantations in different parts of India. Okay, for example, if I talk about Odisha, West Bengal, or parts of Tamil Nadu, let's say Pichavaram, that is why we go for specific, let's say, techniques. Okay, so far, first of all, we've gone through what are the challenges that are there. So I hope that is the first part that you understand, that what are challenges. So number 1, water related, these are hydrological challenges. Okay, here just a couple of points are extra I'll tell you. These challenges can be because of dams, encroachments, can be because of embankments. I'm just telling you what are the challenges that you see. Okay, that is one basic thing. Okay, salinity challenge can be due to many things. Okay, for example, if you think about mangrove Sundarbans, okay, if there is reduced water inflow, or changes in fresh water or saline water inflow, there will be changes in salinity. That's a thing that also happens. Okay, so this is also a part here. Plus one more issue, because of climate change, etc., you can rise sea level rise. That is also a problem. Now soil nutrient imbalance, or that can also happen here. Okay, the soil degradation because of erosion, because of compaction, because of loss of organic matter. Okay, all these things can happen. Right, loss of biodiversity in any ways is a problem. Another challenge is increasing human, right, from deforestation to encroachment, another point that you can link. Okay, so that is also one. Plus the propagules or the natural regeneration itself may also be hampered in these regions. Okay, the propagules, etc., may not be very much present. So all these points are what are the challenges that are there. Okay, so what is the strategy? If you know all these points, just change them. Okay, so for water, you can say hydrological restoration may happen. Okay, so the first point may be, okay, restoring the natural hydrology. Okay, if we do that, then that is better, right, which means better flushing can happen. Okay, for haline or the salinity part, okay, here also, if the fresh water flow is less, we will add more fresh water. We'll try to change this part here. Same for soil. Okay, so soil also we can help it. Again and again I've talked about soil amendments. One of the example of that was vermiculite. Okay, restoration of soil biodiversity or overall biodiversity can happen. Human effects can be minimized. These are some of the ways through which we can go through this. Okay, now here I'll give you a couple of more specific points also, so that you can again write these parts here. So one of the points can be, we can go for planting of certain species. Okay, so artificial planting of mangrove seedlings is important. Again, this is again a part of your strategies. Artificial planting of mangrove seedlings, and here I'll give you the examples of what can be done. Okay, erosion control can be done, because erosion was also a part. Okay, focus on soil stabilization. Okay, this can also happen. Lastly, involvement of local community, because community based efforts are going to help in the long run. Okay, all these things can be carried out to ensure the better reach overall here. Okay, so again, that is one thing to discuss the challenges, etc., strategies. Now we will come to the last part. What are the 5 varieties that you can mention here? Okay, so I think by now there are certain varieties that I have spoken again and again. So one of course is Avicennia marina. We have written it. Okay, or maybe I'll write it here. Okay, just a second. First of all, Rhizophora, Mucronata, Sonartia alba, Avicennia marina. Okay, these are the 3 prominent species that we know. Other 2 species you can also write down. Brugueria species, I'm writing SPP, but there are also specific species here, Brugueria, and there is also a species which is known as Cereops, CERI. Okay, Cereops. You can write down Cereops species or Cereops tagal. Okay, these are all mangrove related species that we can talk about how they are overall helpful. Okay, that is how we can address this particular question. Then the last 2 questions, then we talk about advantages and limitations of selection system in promoting uneven. Please note, so of course when you define it, you will talk about how selection system, because we are going for selection. Okay, in the selection ultimately what you will get, uneven stage is looking like this. This is an uneven stand, different stages. An even stand would be something like this. Okay, same age. This is your uneven stand. Here also you can just mention this. Simple question. Advantages, limitation. If you are going for this uneven stage stand, what are the advantages? Advantages can be, you will have a lot of structural diversity. Okay, which means different canopies will be there. Okay, because of different canopies, the different structures, so you will have different understories. Okay, different dominant, co-dominant. Try to use your keywords wherever you can. Okay, structural diversity will be there. This will also give more avenues for natural regeneration depending on different times when the seeds will follow. This will grow up. Okay, the different kind of canopy plus availability of lights and sunlight resources. This will also go an overall long way. So this can also be mentioned here. Fine. Helps in continuous forest cover. Plus uneven, you are also going to go for selective harvesting. That is the whole part. Selection based system this is. Okay, which is overall sometimes helpful because it is resilient to disturbances. So if there is a particular disease or pest for a particular variety, it is not that the entire stand would get banished. Okay, so it is resilient to disturbances, be it pests, insects. Okay, in that sense it is better, and overall this stand can overall promote biodiversity conservation. Okay, So on all these factors, you see that there are a lot of benefits that we see from this. Okay, so that is one of the way how you will talk about it. But the moment you see it is a selection based system, okay, so there will be a lot of, for example, challenges. The one major challenge is skill. Okay, it requires a considerable amount of skill. Second, also this is more costly in nature, more maintenance, more weeding, more tending operations are required. Okay, so this is so one is very complex. Okay, then you have to have a lot of supervision. What if you remove the better varieties and have the inferior varieties? There can be a problem. Okay, that is there. Sometimes there is a bias for the shade tolerant plants, which also can affect the species composition. That also is seen, but of course that is one. Okay, so these are some of the things that we generally see in this particular case. However, in the long term there are a lot of benefits. Okay, in the long term, of course, there are certain challenges in the long term: ecosystem stability, resilient to pests. Third dimension, climate change. Climate change you can use as a separate dimension again and again. Okay, so on all these fronts you will see that this will contribute to the long term health of the forest, viability, availability of nutrients, soil health, etc. Now you can expand on these points. Fine. And then the last part, we will define mycorrhiza, explain the role in the success of plantation programs, differentiate we have to do between endo and ecto, highlighting the species specific functions in plant soil. Okay, so mycorrhiza, myco is the fungus. Okay, so it is the mutualistic association of the fungus with the roots of higher plants. Okay, this you have to write down. The keyword has to be mutualistic association. Of roots with the higher plant. You have to explain the role. Okay, so there are many things which it helps, but again helps in nutrient cycling, better availability of nutrients, like for example phosphorus. Fine. Overall better absorption, etc. happens. There is something known as mycorrhiza induced resistance. So higher resistance is overall shown. Okay, it will live longer, right? That is also a benefit that happens because of this. So nutrient absorption, okay, also helps in soil fertility. Okay, so a lot of these benefits we can talk about. So if we have a lot of mycorrhiza that is already present, so this will overall promote a lot of this growth. Okay, so better nutrient uptake, better water uptake, better absorption. Okay, that is there. Even the soil structure is improved. Resistance to disease, for example, we can say mycorrhiza induced. Okay, there is also stress tolerance that happens. Okay, and overall, because it improves soil fertility, there is a reduced need for fertilizers. Okay, and then the second part, you have something known as endomycorrhiza and ectomycorrhiza. Okay, and again this kind of question many times keeps on coming, so you should exactly know what is the difference between the two. Okay, so in endomycorrhiza, the main thing is, in endomycorrhiza, the fungus hyphae, they penetrate the cell wall. Okay, main thing is they will penetrate the cell wall overall, whereas in ectomycorrhiza, okay, they form a overall sheath between the root surface, etc., but they do not penetrate the cell wall. That is the overall basic point of difference between endo and ectomycorrhiza. That is how we will understand it. Okay, so again one thing I'll just again repeat: endomycorrhiza, the fungus hyphae, you have to use these exact terms, hyphae, HYPHAE. For this also you can draw a diagram. Okay, the fungal hyphae penetrates the root cell and forms structure inside the plant root cortex. Okay, whereas so in endo it penetrates, in ecto think about ecto as outside, it does not penetrate. It does not penetrate, okay, the root cells. Okay, so that is one part here that you have to understand. Now second thing is, there are two things. One is V and A. Okay, V is your vesicles and A is known as arbuscles. These will be there in the endomycorrhiza. Okay, so it will form arbuscles and vesicles here. Okay, and here overall it will form a dense fungal mantle. Okay, now endomycorrhiza is found in herbaceous plants, whereas ectomycorrhiza is found in woody plants. Okay, so that is also one of the part that we generally see here. Okay, here it is very efficient for absorption of phosphorus, here more for nitrogen, etc. Other points you should know, but the basic point of difference, okay, that whether the hyphae penetrates into the root cell or not is the part that you should understand, and then of course you should give examples and which is more abundant and which is not. That is how we will understand here. Okay, when we say highlighting their specific functions in plant soil interactions, so of course what we've just mentioned we'll talk about. For endomycorrhiza, remember nutrient uptake, broad host range, so across various hosts it is going to be present. Okay, and it helps in better soil structure. Okay, helps in better soil structure is what you will note about. Okay, so right from soil aggregation, nutrient, water, pest resistance, all these points will again be there as a part of plant soil interactions. Okay, I'll again repeat: helps in soil aggregation, carbon sequestration, nutrient cycling, and ecosystem restoration. Okay, so all these parts you have to make sure that you understand well. Okay, so with this we come to the end of this discussion. Okay, I hope this fairly long discussion gave you a lot of points to understand. Go through the model answer as well, and whatever inputs I've given you throughout, be it in terms of diagrams or especially the kind of classifications or mind maps that you can draw while you attempt this particular part here. Okay, so we meet now in the test number 2. I hope you prepare for test number 2 also, which again talks about paper 1B, right from agroforestry to environment conservation, tree improvement, etc. That would be the next topic for us to discuss. Okay, so we'll meet then. Thank you.